Florida is constructing unbelievably large mega projects in 2025. From thrilling new theme parks in Orlando to solar farms in Blodgett, Florida, is turning the entire state around with brand new developments. Today we're diving into Florida's biggest mega projects under construction in 2025 that you must see. Let's travel over to Orlando, where something magical is happening. Literally, Universal Epic Universe is now being called the most ambitious project in the history of Universal. Currently, it's under heavy construction, but already blowing minds. The idea for Epic Universe was announced back in August 2019 by Comcast and Universal Parks and Resorts. The goal was to build an immersive theme park experience that goes beyond anything Universal had ever done before. The construction was suspended in 2020, leading to delays, but by early 2022, development picked up pace again. Now in 2025, the site is buzzing. It's a massive 750-acre property located just a few miles south of existing parks in Universal Orlando. This proposed mega project will be the fourth theme park by Universal in Florida, following Universal Studios Florida, Islands of Adventure, and Volcano Bay. But Epic Universe aims to be different. It's being designed from the ground up as a next-generation theme park, integrating technology, storytelling, and infrastructure in bold new ways. The budget for this project is estimated to be over $1 billion. Some reports even suggest it could reach $2 billion with infrastructure costs and land development. There will be at least 4 major themed lands, each with its own entrance. Confirmed so far is Super Nintendo World, inspired by Mario and other Nintendo franchises. Then there's How to Train Your Dragon, a land designed for younger guests with immersive Viking villages and family rides. Dark Universe will be the ultimate one, based on classic monster films like Dracula and Frankenstein, offering a dark, mysterious experience unlike anything else in the park. In terms of construction, the park uses precast, modular structures, concrete slip formers, and high-capacity tower cranes to build quickly and precisely. Tunnel boring machines are digging underground utility paths, and autonomous forklifts are moving heavy materials with minimal human input. The inclusion of modern technology is beyond inspiring. They're using RFID wristbands for access and payments, facial recognition for guest entry, and even AI-powered crowd control systems to monitor and guide foot traffic. This means shorter lines, better safety, and a smoother guest experience. From automated painters handling wall art to 3D printed signage and props, construction is as much digital as it is physical. Even landscaping is being managed by precision irrigation drones and geo-mapped soil sensors. Once open, Epic Universe is expected to draw millions of visitors annually and create over 14,000 jobs, both in construction and ongoing operations. Next up, we have to talk about the Jacksonville Jaguars stadium renovation, a project so ambitious it could redefine how sports stadiums are built in America. Located in downtown Jacksonville, Everbank Stadium, formerly known as TIAA Bank Field, has been home to the Jacksonville Jaguars since 1995. But in recent years, fans, players, and officials all agreed it was time for something new. That's why the Jaguars and the city of Jacksonville teamed up to launch a $1.4 billion stadium transformation. In 2025, the construction is in full swing and turning heads. The project is being called the Stadium of the Future, and when you look at the details, it's easy to see why. The idea was first announced in 2022, with renderings that stunned the sports world. After negotiations between city officials and the Jaguars organization, construction began in late 2023. Now, in 2025, the stadium is a full-blown construction zone, surrounded by cranes, scaffolding, and non-stop activity. The new design includes a futuristic canopy roof made with a lightweight, transparent material that shields fans from rain and sun without blocking natural light. It will cover over 90% of the seating area and reduce the on-field temperature by nearly 20 degrees. The stadium will also feature outdoor terraces, expanded concourses, 360-degree views, and 5 G-ready smart infrastructure. Everything, from the bathrooms to the concession stands, is being rebuilt with comfort, speed, and technology in mind. The renovation plan includes wider seats, more premium lounges, and upgraded ADA access. There will also be dedicated spaces for community events, youth sports, and even concerts and esports tournaments. Fans will enjoy wider seats, more legroom, and better sightlines from all angles. Underneath the surface, engineers are reinforcing the existing foundation using micropile drilling, ensuring it can support the new steel roof and upper decks. For the structure itself, modular steel trusses are being hoisted into place using crawler cranes that can lift up to 500 tons at once. Construction teams are also working on upgrading all electrical and water systems. New fiber optic lines are being installed for high-speed internet, instant replay features, and augmented reality apps fans can use during the game. It's part of a bigger push to make this a smart stadium. The materials are cutting edge. The canopy will feature lightweight tensile fabric, allowing airflow while keeping out heat. Seating areas are being built with UV-resistant, recyclable materials. The project also includes solar panel arrays to offset the power use of the stadium. By the time the project wraps up, expected in 2028, Jacksonville will have a stadium to support year-round events, from concerts to college games to global tournaments. Next up, we have to talk about the Freedom Park Stadium in Miami, and this one's just reshaping the very identity of urban Miami. In a city known for its nightlife and coastline, this mega project is bringing a whole new kind of energy, a fusion of sport, technology, green living, and economic revival. The idea behind Freedom Park goes back over a decade when soccer legend David Beckham announced his goal to bring Major League Soccer to Miami. But instead of simply building a traditional stadium, the vision evolved into something much bigger, something that could reflect the global image and diverse population of Miami. Today, this 58-acre mixed-use development is under full-scale construction. When it's finished, it will be the official home of Inter Miami CF, including a tech hub, luxury hotels, open retail plazas, and a sprawling public park that's over 70% open green space. That's a rare move in an urban environment, especially one as dense and premium as Miami. The budget is a jaw-dropping $1 billion, making it one of the largest privately funded sports infrastructure projects in the United States. The construction began in late 2022 after years of negotiations, community debates, and environmental planning. Currently, heavy machinery, tower cranes, and robotic arms are working day and night. Laser-guided screeds are shaping the concrete foundation. Hydraulic jacks are lifting massive roof structures into place with pinpoint accuracy. Every piece of the stadium is being engineered to meet global eco standards, meaning zero waste plans, solar rooftops, and greywater recycling systems are built into the core of the design. The stadium will seat 25,000 fans. The layout is compact, modern, and incredibly high-tech. Inside, augmented reality tools are helping guide structural alignments. On the outside, modular panels are being installed using crane-mounted robotic arms, reducing errors and speeding up the timeline. The seating system in the stadium is automated. Specialized robotic systems position, drill, and bolt seats at scale. This type of precision not only saves time, but also improves durability and reduces maintenance costs long-term. Built on the former Melrose Country Club near Miami International Airport, the site offers excellent accessibility. A future transit station is in the works to connect the site to broader Miami, encouraging public transport use over car dependency. Once complete in 2026, this mega project is expected to create thousands of permanent jobs, boost local tourism, and generate over $40 million annually in tax revenue. Let's talk about the West Shore Interchange project in Tampa, one of the most complex and ambitious transportation mega projects underway in Florida in 2025. Located where Interstate 275 meets State Road 60 The West Shore area is one of the most vital traffic corridors in the state. It connects major destinations like the Tampa International Airport, downtown Tampa, the West Shore Business District, and nearby residential neighborhoods. For decades, this area has been a known traffic bottleneck, with frequent gridlock, crashes, and inefficient routes for commuters and freight trucks alike. The project has been in planning for more than 20 years, as transportation officials gathered data and input from the public to create a design that would actually solve the long-standing congestion issues. It finally broke ground in 2023, and in 2025, the project is hitting full throttle. The budget is projected at around $1.6 billion, funded through a combination of state, federal, and local sources. This massive investment reflects the critical importance of the interchange for the entire Tampa Bay regional economy and mobility. The redesign is nothing short of transformational. The project includes additional general use lanes, elevated flyovers, wider ramps, and dedicated express lanes to streamline traffic. There's also a strong focus on multimodal access, including dedicated bus lanes, protected pedestrian walkways, and bike-friendly routes. The construction plan is divided into phases, with the current phase in 2025 focusing on realigning key ramps and completing bridge structures. Massive steel box girders, some over 150 feet long, are being moved using multi-axle hydraulic transporters and positioned with high-capacity crane towers. Crews are using 3D modeling, ground-penetrating radar, and automated road grading systems to ensure precision and reduce costly errors. GPS-guided bulldozers, automated paving machines, and concrete slip farmers are working around the clock. Some sections of the road are being pre-assembled off-site using modular construction techniques, speeding up the timeline while reducing noise and dust in residential zones. Below the surface, advanced stormwater management systems are being laid using tunnel boring machines. These will help prevent future flooding and keep the road safer during Florida's intense rainy seasons and hurricanes. Once completed in 2027, the West Shore interchange will reduce travel times by up to 40%, dramatically improve safety, and allow for faster evacuation routes during emergencies. It will ease the burden on the airport, open access to growing economic hubs, and allow smoother freight movement between the port and major inland highways of Tampa. Let's travel over to Miami Gardens, where a brand new urban heartbeat is under construction. Located in the heart of Miami-Dade County, this mega project is transforming 200 acres of unused land into a dynamic, mixed-use destination. The project was first proposed in 2018 as part of the city's broader push for economic revival and cultural visibility. After years of planning, groundwork officially began in late 2021, and currently the site is buzzing with activity. The planned Miami Gardens City Center is a large, mixed-use development featuring entertainment, restaurants, residential units, hotels, and more, with a focus on catering to tourists and residents alike, including a 50,000 square foot dinner show. The budget is estimated to be around $650 million. That money is being invested in phases, with different developers handling the commercial, residential, and recreational elements. In its current phase, construction crews are building luxury apartments, a shopping promenade, and a central plaza. The design includes green rooftops, solar energy systems, and water-smart landscaping, making it one of the most eco-conscious urban projects in Florida. For decades, Miami Gardens has struggled with limited economic growth, despite being home to iconic locations like Hard Rock Stadium. The new city center will bring in retail chains, locally owned businesses, and high-end restaurants, helping to keep tourism alive in the community. It will also provide more than 2,000 jobs in the next 2 years, both in construction and post-completion retail, hospitality, and maintenance roles. The architecture blends modern glass structures with open-air courtyards and pedestrian-friendly boulevards. The construction involves tilt-up concrete panels, modular steel frames, and rapid-setting concrete mixers to stay on schedule. Tower cranes and automated rebar tying robots help speed up vertical construction. Underground workers are laying down a state-of-the-art fiber optic backbone that will support everything from smart lighting to Wi-Fi zones and security systems. This tech will allow residents and visitors to navigate the city centre with real-time information on parking, traffic, and events. The landscape plan is even impressive. Over 1,000 trees will be planted, many of them native species that support the fragile ecosystem in Florida. Bioswales and rain gardens are being added to naturally filter stormwater and reduce runoff. By 2027, the Miami Gardens City Center will be fully operational. But even in 2025, it's already reshaping the skyline. Residents who've lived in the area for years are seeing the future unfold right outside their windows. Let's move over to another giant transformation in Tampa, the I-275 Capacity Improvement Project. If you thought the West Shore Interchange was big, this one might just surprise you. Interstate 275 is the main highway of the famous Tampa Bay, running straight through the city. This $580 million mega project is about widening, modernizing, and future-proofing one of the most congested freeway stretches of Florida. It targets the corridor from north of the downtown interchange to Bears Avenue, a section that regularly sees bumper-to-bumper traffic. The project is a direct response to the rapid growth of the region, with Tampa and nearby areas adding over 100,000 new residents in recent years. More people means more traffic and more pressure on aging infrastructure. The project officially launched in late 2022, and in 2025, construction is fully underway. Crews are focused on adding one new general use lane in each direction, upgrading interchanges, and installing intelligent transportation systems to improve traffic flow. The project includes widened shoulders, noise-reducing walls, stormwater upgrades, and LED roadway lighting. There's also a special focus on safety with enhanced guardrails, crash cushions, and barrier walls being installed. Construction is happening in phases to avoid full shutdowns and keep traffic moving. Day and night shifts are being used, along with lane management strategies that help limit closures during peak hours. To speed things up, crews are using automated grading machines, paver finishers, and laser-guided concrete cutters. For structural work, precast box culverts and modular retaining walls are being dropped into place using hydraulic cranes. Real-time sensors continuously track pavement compaction. Drones monitor construction progress and detect any errors. BIM software is used for scheduling, clash detection, and team coordination. What makes this project especially modern is the use of adaptive traffic control systems. These systems will allow traffic lights and highway signs to respond automatically to real-time conditions, accidents, or weather problems, helping drivers make faster, safer decisions. Diverse fiber optic cables are being embedded along the roadbed. These will support future autonomous vehicle technology and allow faster emergency response communication. The project also includes multi-use paths and pedestrian bridges, making it safer for those who walk or bike in the area. Once complete, targeted for 2026, the I-275 expansion will cut travel delays, increase road capacity, and reduce accident-related closures. It's a critical piece of the puzzle for the vision of Florida to build and maintain a seamless, high-tech highway network. But just wait until you hear about the Howard Franklin Bridge expansion, a mega project that's reshaping Tampa Bay in real time. If you've ever driven between Tampa and St. Petersburg, chances are you've crossed the Howard Franklin Bridge. It's one of the most traveled bridges in Florida, carrying nearly 180,000 vehicles each day across Old Tampa Bay. For years, locals have dreaded the traffic jams, bottlenecks, and delays on this vital link. The current structure, built in 1959, has long been overdue for an upgrade. That's why the Department of Transportation in Florida launched this massive expansion project to bring safety, capacity, and resiliency to this crucial corridor. The project officially kicked off in 2020, and in 2025, it's hitting a critical phase. The work involves building a completely new parallel bridge structure just south of the existing one. This new bridge will carry 8 lanes, 4 in each direction, including express lanes, general use lanes, and a dedicated multi-use path for pedestrians and cyclists. When completed, the older 1960s bridge, currently northbound, will be demolished. The newer southbound span, built in 1990, will be converted for northbound traffic. In short, you'll have 2 modern bridges, both equipped for today's traffic volumes and tomorrow's needs. The budget for the project is approximately $865 million. It's being funded by the Strategic Intermodal System, which focuses on infrastructure critical to the movement of people and goods. Construction techniques on this bridge are state-of-the-art. Teams are using floating cranes, barges, and pile-driving rigs to install more than 3,000 concrete piles deep into the bay floor. These piles form the foundation of the superstructure of the new bridge. Girders are precast off-site and shipped to the project via barge, then lifted into place with massive gantry cranes. Each girder weighs over 100 tons. The bridge deck is formed using pre-stressed concrete segments, allowing for rapid assembly and minimizing disruptions to existing traffic. The construction teams are working under strict environmental guidelines to protect the sensitive ecosystem of the bay. Special silt curtains and turbidity barriers are being used to prevent sediment from spreading. The bridge is being designed with elevated clearances to help protect against future sea level rise and storm surge events. Howard Franklin Bridge is a lifeline between 2 of the fastest growing cities in Florida. It supports commuters, tourists, freight trucks, and emergency responders. Once finished in 2026, the new bridge will reduce congestion by up to 50%, cut travel times, and provide hurricane-resilient infrastructure that can keep Florida moving, even in a crisis. Let's talk about the Ocean Terrace redevelopment in Miami Beach, a project that's blending luxury, history, and sustainability into one stunning transformation. Located in the North Beach neighborhood, Ocean Terrace was once a glamorous oceanfront strip filled with Art Deco hotels and bustling shops. But over the decades, it faded. Old buildings fell into disrepair, and tourism shifted elsewhere. The area needed a reboot, and now, in 2025, it's getting exactly that. The Ocean Terrace redevelopment project is a $1 billion mega project designed to turn this once forgotten stretch into a modern beachfront paradise. The plan involves demolishing several aging buildings while preserving and restoring historic facades. In their place, developers are building luxury condos, a boutique hotel, retail spaces, and a revamped public beachfront park. The architectural vision is led by Arquitectonica, one of the most respected firms in Miami. The buildings will blend modern glass towers with vintage Art Deco design, creating a unique look that honors Miami's past while embracing its future. The project broke ground in 2023, and at present, construction is roaring. Workers are laying the foundations for 18-story residential buildings with underground parking garages that can handle both flooding and storm surges. Miami Beach is vulnerable to sea level rise, so developers are raising the entire site elevation using structural fill, stormwater vaults, and elevated podium decks. The buildings are being constructed with hurricane-resistant glass, reinforced concrete cores, and wind load certified materials. Heavy-duty excavators and drilling rigs are prepping the foundations, while prefabricated steel framing is delivered by barge to minimize road traffic. Crews are also using low-carbon concrete mixes to reduce emissions on site. One of the most impressive features is a 2-acre public plaza, an oceanfront park with bike lanes, shade trees, event spaces, and direct access to the beach. This green zone will be open to everyone, not just residents or hotel guests. The condos, priced in the millions, will offer floor-to-ceiling ocean views, smart home automation, green HVAC systems, and on-demand concierge services. The hotel will include a rooftop infinity pool, spa, fine dining, and luxury retail outlets. This redevelopment is expected to bring in thousands of jobs, from construction workers to hospitality staff to long-term retail operators. Once completed in 2029, this mega project will revive tourism in North Beach, pulling visitors back to an area that was once a cultural hotspot. Next up is the Kelso Solar Farm, and this one's a major step forward for clean energy in Florida. Located in Blodgett, just outside of Tallahassee, the Kelso Solar Farm is a massive renewable energy project aiming to power tens of thousands of homes without burning a single ounce of fossil fuel. The farm will cover over 3,000 acres of land and feature more than 800,000 solar panels. When fully operational, it's expected to generate 300 megawatts of electricity, enough to power about 60,000 homes. That's a huge deal for a state that relies heavily on natural gas, and where demand for electricity keeps rising year after year. The Kelso Solar Farm is using some of the most advanced solar technology available. Each panel is mounted on a single-axis tracking system that follows the sun across the sky. This means more sunlight captured, more power generated, and higher efficiency all day long. These trackers are operated by AI-based control systems that adjust in real time based on cloud cover, shading, and even bird activity. Crews on site are using automated pile drivers to install the support beams into the ground with laser precision. Once installed, robotic arms place the panels, reducing the risk of damage and speeding up the entire process. The wiring infrastructure is massive too. Miles of underground cabling are being installed using plow trenches, ensuring that the landscape remains as untouched as possible. The system is being built with high voltage inverters, battery storage units, and smart grid connectivity that allows the power to flow instantly when needed. The battery storage component is another highlight. Kelso Solar Farm will have 120 megawatt hours of battery capacity, allowing it to store energy during the day and feed it back into the grid at night. That's crucial for balancing Florida's energy load and preparing for peak demand times. The budget for this project is close to $500 million, funded through a mix of private investment and green energy incentives provided by the state and federal governments. Construction began in 2023, and currently the farm is about 70% complete. Rows of solar panels already stretch to the horizon, and the control center is being built with sustainable materials, including recycled steel, solar roof tiles, and rainwater harvesting systems. Let's move over to Tallahassee, where one of the most respected universities in Florida is building a mega project that's all about the future of education and business leadership. Legacy Hall will be the upcoming home of the Florida State University College of Business. This mega project is a $120 million landmark designed to reshape how business is taught, learned, and lived. This monumental building will span over 218,000 square feet, making it the largest academic space ever constructed on the Florida State University campus. It will include tech-enabled classrooms, behavioral research labs, student collaboration spaces, and a 300-seat auditorium for lectures and events. Construction began in early 2023, and by 2025, much of the structure is in place. Crews are working on exterior glass panels, interior framing, and mechanical systems. The building is being constructed with energy-efficient systems, sustainable materials, and low-emission processes. The roof is being outfitted with solar panels and a rainwater collection system for on-site landscaping. Inside, the focus is on student-centered design. There will be open-air atriums, flexible learning spaces, and tech lounges with 24-hour access. Think Wi-Fi mesh networks, digital touchboards, and motion sensor lighting, all part of creating a smarter learning environment. The construction techniques are modern and efficient. Crews are using prefabricated wall assemblies, steel-reinforced floor slabs, and automated drywall robots to maintain quality while keeping the project on schedule. Elevators and escalators are being installed with regenerative drive systems that recapture energy and reuse it within the building.
Next on our list is the remarkable Salton Sea Restoration Project. This project is not only huge in scale, but also critical for the environment and public health. Once a popular tourist destination, the Salton Sea has now become one of the most polluted bodies of water in the country, with dust storms spreading toxic chemicals into nearby communities. The Salton Sea Restoration Project is part of the 10-year Salton Sea Management Program. The $400 million restoration plan includes reducing harmful dust and creating sustainable habitats. The first phase of this project is still underway, primarily focusing on restoring wildlife habitats, stabilizing air quality, and mitigating the effects of the receding waters in the sea. Let's talk about some of the engineering marvels and techniques being used. One of the most critical components is the Species Conservation Habitat Project, which broke ground in 2021. This project will restore approximately 4,100 acres of shallow water habitats that have been lost due to rising salinity in the sea. By reintroducing shallow water environments, the project aims to protect fish and bird populations, especially those on the Pacific Flyway. The North Lake Project is another ambitious project within the SSMP. By restoring 1,600 acres of aquatic habitat, this project will benefit local biodiversity and water quality. The North Lake Pilot Demonstration Project is already in development, acting as a testing ground for the full-scale restoration. Next, we'll see vast stretches of land once barren, now covered in lush vegetation. Native plants like cattails and bulrushes are being used to stabilize exposed areas of the lake bed. These plants help to anchor the soil, reducing the risk of wind-blown dust that carries toxic particles in the air. Restoring vegetation along the shoreline doesn't just improve air quality, it creates new habitats for local wildlife. The restoration doesn't stop there. Projects like the Desert Shores Channel Restoration aims to refill boat channels that were once popular in the Desert Shores Marina. By reintroducing water into these channels, the project supports both local recreation and environmental health. The Audubon Bombay Beach Wetland Enhancement Project is another exciting initiative, focusing on restoring 832 acres of vital wetland habitat. This project will benefit countless migratory birds and fish, making the Salton Sea a haven for wildlife. The federal government has committed $175 million for the Inflation Reduction Act to accelerate restoration efforts. This complements over $500 million in state funding, providing a significant boost to the ongoing projects. One of the main goals is to address air quality issues caused by the shrinking sea by creating a network of ponds and wetlands designed to support wildlife and reduce dust emissions. The restoration plan isn't just about improving the environment, it's a lifeline for the local community. It's super exciting to see such a large-scale project effort dedicated to restoring a natural treasure while protecting public health.
But how about an entire stadium being replaced? The Aloha Stadium Replacement Project, located in Halawa, Hawaii, is a significant undertaking aimed at revitalizing the sports and entertainment capabilities of Hawaii's most populous island, Oahu. This ambitious project replaces the aging Aloha Stadium, originally built in 1975, which had become increasingly costly to maintain and no longer met modern safety or functionality standards. Scheduled for completion in 2028, the new stadium complex is anticipated to cost over $350 million. The project covers an extensive area of approximately 98 acres, with the new stadium expected to seat around 35,000 spectators, down from the old stadium's capacity, but designed to offer improved sightlines and amenities. This size makes it comparable to the StubHub Center in California, though with enhanced technological integrations, employing around 2,000 workers during peak construction phases. The project faces the unique challenges of building in an island setting, such as logistics complications related to material shipping and the high cost of labor and supplies in Hawaii. The new stadium will employ modern construction techniques, including the use of sustainable materials and energy-efficient designs to minimize its environmental footprint. Features like solar power generation and water reclamation systems are planned to make it one of the greenest stadiums in the nation. A key problem that the new Aloha Stadium aims to solve is the economic inefficiency of its predecessor. The old stadium was underutilized, partially due to its deteriorating condition and lack of modern facilities that limited event hosting capabilities. The new complex, with its state-of-the-art features, seeks to attract more high-profile events and consequently generate significant economic benefits for the region. One innovative aspect of the project is its integrated approach to development. The stadium complex will include mixed-use developments such as hotels, retail spaces, and residential areas, creating a vibrant community hub rather than just a sports venue. This model follows the trend seen in projects like the Atlanta Braves' Truist Park, which integrates a stadium with a larger commercial and residential district. But what about the expansion of a massive airport? The O'Hare International Airport expansion is one of the most ambitious airport revitalization efforts in the world. Located in Chicago, Illinois, this massive undertaking aims to propel O'Hare into the future of aviation. With a projected budget of $8.5 billion, this expansion is not just a facelift, but a complete transformation aimed at increasing capacity and improving efficiency. Officially launched in 2019, the O'Hare 21 project is slated for completion in 2028. It includes a major overhaul of Terminal 5, the construction of a new Global Terminal 2, and the addition of 2 new satellite concourses. These improvements will expand terminal space by a staggering 60%, allowing O'Hare to handle the anticipated increase in passenger traffic, which is expected to exceed 100 million passengers annually by the project's completion. The centerpiece of the expansion is the new Global Terminal, designed to be the first of its kind in the United States, which will replace the existing Terminal 2. The terminal will cover approximately 2.2 million square feet, making it one of the largest aviation facilities in the country, roughly equivalent in size to 35 football fields. Construction at one of the busiest airports in the world presents unique challenges, particularly maintaining day-to-day operations while managing massive construction efforts. The project employs over 5,000 workers, utilizing innovative construction methods such as prefabricated materials and modular construction techniques to minimize disruption. These methods not only expedite the building process, but also help manage the logistical complexities of working within an operational airport. The O'Hare expansion will also address some of the airport's long-standing issues, such as congestion both on the tarmac and inside the terminals. By redesigning gate layouts and improving the configuration of taxiways and runways, the project aims to significantly reduce taxi times and delays, thus solving a critical problem that has plagued O'Hare for decades.
But just wait until you hear about the Buffalo Bills Stadium, officially named Highmark Stadium. Located in Orchard Park, New York, the project aims to give fans an unparalleled game day experience while boosting regional pride. The original Highmark Stadium, built in 1973, has served as the home for the Buffalo Bills for 5 decades. However, the aging structure no longer meets the demands of modern football or fans. In response, a new $1.5 billion project was approved in 2022, marking the largest investment in Buffalo sports history. The new Buffalo Bills Stadium will cover 1.35 million square feet with a seating capacity of 6,000 talents. It will feature a partial canopy roof to protect fans from Buffalo's unpredictable weather while maintaining an open-air field to preserve the essence of outdoor football. The design includes state-of-the-art amenities like advanced video boards, immersive sound systems, and expansive concourse areas. Enhanced VIP suites, fan zones, and technology-driven experiences aim to elevate spectator engagement. Construction began in early 2023 and is set to complete by the 2026 NFL season. The project uses modular construction techniques, allowing for faster assembly and better quality control. High-strength steel and precast concrete ensure the structure's durability and safety. One of the most impressive aspects of the stadium is the canopy structure. Engineers are using high-strength steel and tension cables to create a lightweight yet durable canopy system. This design minimizes obstructions, ensuring clear sightlines for fans while withstanding harsh weather conditions, including heavy snow and high winds. The foundation of the stadium required extensive excavation and reinforcement to accommodate the weight of the canopy and ensure long-term stability. Advanced drainage systems are being installed to handle Buffalo's frequent rainfall and prevent water damage to the structure. Prefabrication techniques are being used to speed up construction. Components of the canopy and seating sections are manufactured off-site and assembled on-site, reducing costs and construction time. The stadium incorporates sustainable practices, such as energy-efficient systems and rainwater harvesting. Materials are sourced locally to minimize environmental impact, aligning with Buffalo's commitment to green development. The project is expected to create 10,000 jobs during construction and inject millions into the local economy. Once completed, the stadium will host NFL games, concerts, and events, making it a year-round hub for activity and revenue.
But what about one of the tallest skyscrapers in New York City? Located in the bustling Hudson Yards district of Manhattan, the Spiral Tower stands as a pinnacle of architectural innovation and modern design. Officially known as 66 Hudson Boulevard, this towering skyscraper reached its completion in 2022, emerging as one of the most distinctive profiles against the Knicks skyline due to its spiraling green terraces that ascend with the building's rise. The spiral spans 65 stories, measuring approximately 141 feet in height. The project carried a substantial financial commitment, with development cost estimated at around $3.7 billion. The construction of the spiral employed approximately 7,600 workers across various phases, reflecting its scale and the complexity of its design. This architectural marvel was conceived to offer a blend of premium office spaces and expansive green outdoor terraces on each floor, integrating nature into the urban workspace. Each terrace is equipped with foliage and seating areas, providing accessible outdoor space to office occupants, a rare feature in Manhattan's dense urban landscape. The construction of the spiral involved innovative building techniques, particularly in the integration of its steel superstructure with the cascading terraces. Advanced computer modeling and precision fabrication were crucial to ensuring that each floor's outdoor space seamlessly aligns with the spiraling design. The spiral's total floor area is about 2.8 million square feet, roughly equivalent to the size of 50 football fields. However, the project wasn't without challenges. Its construction phase coincided with a pandemic, which posed significant logistical challenges, delaying materials and reducing workforce efficiency due to health and safety protocols. Yet, the project team adapted with enhanced safety measures and scheduling adjustments to mitigate these impacts.
Bay Area Rapid Transit Expansion is the next project on our list. If you live in or around San Francisco, you probably know how essential BART is for getting around. The Bay Area is one of the most densely populated regions in California, projected to include over 9 million people by 2040. That's why BART is undergoing its biggest expansion. The Silicon Valley Extension is a $6 billion project designed to extend BART service deeper into Silicon Valley, eventually reaching San Jose. This isn't just about adding more tracks. Phase 2 of the expansion will see the construction of 3 brand new underground stations. There will be a massive tunnel boring machine cutting through downtown San Jose. By 2026, commuters will have a faster, cleaner, and more efficient way to travel. Now let's dive into some impressive engineering behind this massive project. BART is relying on cutting-edge tunnel boring technology for the underground portion of the extension. Tunnel boring machines are essentially underground factories. These colossal machines can measure over 300 feet long and weigh up to 3,000 tons. As they dig, TBMs simultaneously install precast concrete segments to reinforce the tunnel walls, speeding up the construction process by ensuring the tunnels are structurally sound. In the future, they'll easily withstand the natural movements of the Earth. What's even more impressive is the scale of the Silicon Valley Extension. At 6 miles, it's the largest public infrastructure project ever attempted in Santa Clara County. Think of the impact of 4 new stations on the daily lives of thousands of commuters. 28th Street, Little Portugal, downtown San Jose, Durandon, and Santa Clara. Each station is designed to handle the growing number of people commuting in the Bay Area. With an estimated completion date of 2026, this extension promises to revolutionize the way people travel, saving precious hours each day. The train control modernization project is one of the major elements tied to this expansion, enabling trains to run more frequently and reliably, allowing you to catch the next one without a long wait. This technology will enable trains to run closer together, especially during peak hours. It's not just about adding more tracks, it's about optimizing the existing system to maximize capacity. By 2040, BART aims to transport nearly 55,000 passengers daily on this extended system. That's a staggering number, reflecting the growing demand for efficient public transportation in the Bay Area. But with great ambition comes great cost. The total cost of Phase 2 has escalated from $4.7 billion to a staggering $12.8 billion. Despite this massive price tag, the potential benefits are beyond expectations. Reduced traffic congestion, faster commutes, and a more sustainable transit system make this investment a worthwhile effort. BART's fleet of the future is not just about adding more trains, it's about revolutionizing the passenger experience. These new energy-efficient trains are designed to be quieter, more accessible, and more comfortable. Commuters will experience smoother, quieter rides with better amenities. This modernization effort, coupled with the Silicon Valley extension, is part of a larger vision, Link 21. BART aims to build a new Transbay rail crossing, alleviating congestion on the existing Transbay tube and increasing capacity for both BART and regional rail services.
We travel over to San Francisco next for the redevelopment of their international airport. This expansive project, known as the Airport Development Plan, is set to reshape the airport by enhancing capacity and passenger experience through a series of ambitious construction initiatives. Commenced in 2016 with a strategic plan, the development is budgeted at over $7 billion. One of the cornerstone projects within this expansion is the renovation of Terminal 1, a project that began in 2016 with a budget of approximately $2.4 billion. The terminal's revamp includes the construction of a new boarding area with additional gates, upgraded baggage systems, and new dining and retail spaces. The airport's plans also include the enhancement of airfield safety. These changes are designed to improve the efficiency of aircraft movements on the ground, thereby reducing taxi times and minimizing delays. San Francisco International Airport is also focusing heavily on sustainability, aiming to become one of the world's first zero-net energy airport campuses. Solar panels, energy-efficient buildings, and water conservation systems are integral to this vision. The challenges of executing such a vast project in an active airport environment are immense. Construction teams have had to carefully phase their work to minimize disruption to travelers, manage noise levels, and ensure that airport security is uncompromised.
Next up, we have to talk about the $119 billion New York City seawall project, an ambitious response to rising sea levels and increasing storm surges. Known as the Big U, this protective infrastructure aims to shield the city from the devastating effects of climate change. The devastating impact of Hurricane Sandy in 2012 underscored the vulnerability of the city to extreme weather events, with over $70 billion in damages. In response, the U.S. Army Corps of Engineers developed the New York Harbor Storm Surge Barrier Plan. The seawall will stretch approximately 6 miles along the coastline, acting as a barrier to shield New York Harbor and Lower Manhattan from extreme weather events. This ambitious project will storm gates, levees, and natural wetlands restoration to absorb water and reduce storm impact. This 20-foot tall seawall is part of a $10 billion plan to climate-proof New York City. It will include a public walkway that can host events like concerts and marathons. Building a seawall of this magnitude requires advanced engineering to ensure resilience against powerful storms and rising tides. Engineers are using a combination of reinforced concrete and steel structures to construct the barrier. Deep foundation piles are driven into the seabed to anchor the wall securely. The project also integrates movable storm gates, which can close during severe weather and reopen for normal maritime traffic. Hydrodynamic modeling and simulations were conducted to optimize the design and placement of walls. Advanced modeling techniques, including AI-based simulations, have been employed to predict storm behavior and optimize barrier placement. The wall incorporates tidal gates to maintain water flow and preserve the ecological balance of the harbor. Some sections feature living shorelines, blending natural habitats with engineered defenses to promote biodiversity and reduce wave energy. The project involves dredging, reinforced piling, and innovative materials resistant to erosion and saltwater corrosion. Despite the staggering cost of $119 billion, the seawall is projected to save over $200 billion in potential damages. Once completed, the seawall will protect New York City from catastrophic flooding and redefine urban waterfront living.
Next up, it's time to talk about the Bob Graham Sunshine Skyway Bridge project. Opened in 1987, this bridge is not just a crucial conduit connecting St. Petersburg with Terra Sia, but also a masterpiece of engineering. Spanning a total length of 4.1 miles, with a soaring cable-stayed section that stretches 1,200 feet between pylons, the Sunshine Skyway Bridge stands as one of the longest cable-stayed concrete bridges in the world. Constructed at a cost of $244 million, it was developed in response to a catastrophic collision in 1980, when the original bridge was struck by a freighter during a storm, causing a portion to collapse. This new bridge was designed to prevent such a disaster from recurring, featuring 430-foot-tall pylons and a road deck that rises 193 feet above the water, allowing ample clearance for ships passing underneath, thus significantly mitigating the risk of ship collisions. The design of the Sunshine Skyway Bridge integrates advanced engineering techniques, including the use of high-strength, corrosion-resistant steel and aerodynamic concrete pylons, ensuring durability against harsh marine conditions and the threat of hurricanes. The bridge's cables, if laid end-to-end, could stretch over 300 miles, long enough to reach from Tampa to Key West. The construction process itself was a monumental task, employing over 1,000 workers at its peak. These workers braved the challenging conditions of open water to erect the massive pylons and hang the bridge's 21,000 miles of cable. The project not only demanded precision in execution, but also required innovative solutions to minimize environmental impact. But what about the redevelopment of an entire train station? That's what happened with New York's Moynihan Train Hall. This grand project, completed in January 2021, seamlessly blends state-of-the-art facilities with historic architectural elements. The project cost approximately $1.6 billion, a strategic investment aimed at reviving the Midtown area and providing New York commuters and travelers with a more dignified and spacious environment. Construction of the train hall was a logistical challenge, requiring the coordination of thousands of workers in a densely populated urban area. The workforce fluctuated throughout the project, peaking at around 1,200 workers during its most intense phases. These individuals were involved in intricate tasks ranging from restoring the century-old steel trusses to integrating modern technology and security systems within the structure. The Moynihan Train Hall solves several pressing problems associated with the original Penn Station: overcrowding, lack of natural light, and limited amenities. By expanding into the Farley Building, the project has effectively increased the station's total footprint, allowing it to serve up to 700,000 passengers daily. The hall's design features a dramatic 92-foot-high skylight that arches over the main concourse. This skylight, covering an area of 31,000 square feet, not only illuminates the space with natural light, but also serves as a modern counterpoint to the Farley Building's Beaux Arts facade. Next up, it's time to visit the Mackinac Bridge project. Known affectionately as Big Mac or Mighty Mac, this bridge links Michigan's upper and lower peninsulas, thus uniting what nature had divided. Located in Michigan, the Mackinac Bridge was completed in 1957 after 3.5 years of construction, overcoming numerous challenges posed by geography and climate. At the time of its completion, the Mackinac Bridge was the world's longest suspension bridge between anchorages, a title it held for many years. Spanning an impressive total length of about 5 miles, with a central span of 3,800 feet, the bridge was a marvel that required extraordinary engineering prowess and innovation. The construction cost was approximately $100 million, equivalent to nearly $1 billion today. Constructing the Mackinac Bridge was a colossal undertaking involving the coordination of hundreds of workers. The project faced many challenges, including harsh weather conditions that could change swiftly, posing risks to workers and the structural integrity of the emerging bridge. Winter gales and fog were routine obstacles that required innovative solutions, such as heated scaffolds and special gear for workers. One of the most notable aspects of the Mackinac Bridge's construction was the use of pioneering techniques for deep water caisson construction. These massive caissons were sunk to depths of up to 210 feet below the water's surface, a groundbreaking achievement at the time. The bridge's towers, standing at 552 feet above water level, required the transportation and assembly of thousands of tons of steel, sourced from mills across the United States. The Mackinac Bridge greatly simplified travel between the two peninsulas, which previously relied on a ferry service that was often hindered by ice in winter. The total amount of steel used in the bridge, approximately 20 tons, is enough to build nearly 400 tanks.
The Echo Water Project in Sacramento is a massive undertaking, and it's making waves, literally. With a budget of $1.7 billion, this project is transforming how California manages its water amid a historic drought. California is no stranger to water crises. The recent years have only intensified the challenges. In 2022 alone, California recorded one of its driest years ever, forcing more than 600 square miles of farmland to be left fallow due to the insufficient water supply. But with the completion of the Echo Water Project, there's hope on the horizon. The biological nutrient removal facility is the crown jewel of the Echo Water Project. The B&R facility consists of 8 massive basins filled with specialized tubes that release oxygen into the wastewater. This process supports the growth of bacteria, which in turn removes 99% of ammonia and 89% of nitrogen from the water. These harmful chemicals are responsible for polluting waterways and contributing to environmental degradation. With the B&R facility in place, the treated water is much cleaner and safer to release into the environment. The project also includes a network of tertiary treatment facilities, where the water undergoes further filtration and disinfection. These facilities are a marvel of modern engineering, constructed with over 40,000 tons of steel and 170,000 cubic meters of concrete. These giant concrete structures, pumping stations, and electrical installations work together to ensure the highest level of water treatment. The digital twin of the entire facility was used during the construction phase. This digital twin is a virtual replica of the wastewater treatment plant, allowing engineers, contractors, and designers to visualize and manage every aspect of the construction process in real time. Jeff Campbell, director of virtual planning, explained, "We had a very strict concrete pour requirement of this project, so we really couldn't afford a lot of leaks." This project broke ground in 2015 and took 7 years to complete. With construction finishing in 2022, managing such a large project was no easy task, especially since the wastewater treatment plant had to remain operational throughout the entire process. With 22 individual projects running simultaneously, the complexity of the build was immense, but thanks to digital twin technology, the project was completed without major delays and even came in $400 million under budget. Now that the Echo Water Project is operational, it's not just about cleaning wastewater, it's about putting that water to good use. By 2025, the project will be a crucial component in agricultural reuse and sustainable farming efforts in southern Sacramento County. A new pump station and pipelines will direct to treated water from the plant to agricultural land. This will reduce the need for groundwater pumping, allowing aquifers to recover. Up to 16,000 acres of farmland will be irrigated with this reclaimed water. This offers a sustainable solution for agriculture, which has been devastated by years of drought and falling crop revenues. The Echo Water Project is a blueprint for the future that'll help California manage its water crisis head-on. With the ability to treat and reuse millions of gallons of water every day, the Echo Water Project is not just helping today, it's preparing California for tomorrow.
Let's travel over to North Carolina, where the Charlotte Gateway Station is being constructed. This significant development, a central hub designed to integrate various modes of transportation, including Amtrak, buses, and future light rail services, is part of a larger vision to improve transit connectivity across the region. Scheduled for full operational status by 2025, the Charlotte Gateway Station began its early phases in 2018 with a budget projected to exceed $800 million by the project's conclusion. The station itself will cover several city blocks, featuring a state-of-the-art passenger terminal, bus bays, and extensive parking facilities. The project's total area is comparable to 20 football fields, emphasizing its scale and the transformational impact on the city landscape. It is expected to serve thousands of passengers daily, significantly easing the city's traffic congestion and providing a more efficient, reliable public transportation network. One of the primary challenges has been coordinating the multiple phases of construction while minimizing disruptions to the existing traffic and businesses in downtown Charlotte. The station's design features include expansive glass facades to maximize natural lighting and open public spaces that encourage pedestrian traffic, reflecting new trends in urban station aesthetics and functionality. In comparison to other transportation projects like the Moynihan Train Hall in New York City, the Charlotte Gateway Station is unique in its incorporation of green building practices and its role in catalyzing economic development in a mid-sized American city. Despite challenges such as budget adjustments and the complex logistics of constructing in a dense urban core, the Charlotte Gateway Station is set to become a critical node in North Carolina's transportation network.
But have you ever heard about the remarkable Spiral Tower? Rising 1041 feet above Hudson Yards in Manhattan, the Spiral is a $3.7 billion skyscraper that redefines sustainable and innovative architecture. The Spiral was conceived as a mixed-use development offering office spaces, retail, and public amenities. Its name comes from the cascading terraces that spiral around the building, creating a continuous ribbon of green spaces from top to bottom. This unique feature connects all floors with landscape terraces, symbolizing an architectural evolution toward greener urban environments. The tower provides 2.85 million square feet of office space and luxurious amenities. A striking feature is its 66th floor, open-air terrace and clubhouse, offering panoramic views of the city. The interiors seamlessly blend modern aesthetics with functionality, creating an atmosphere of sophistication. Its facade features high-performance glazing to maximize natural light while minimizing heat gain, contributing to energy efficiency. The advanced irrigation system conserves 4.5 million gallons of water annually compared to traditional systems. Its construction involved modular building techniques, accelerating the assembly of its complex design. Steel and concrete were the primary materials, ensuring structural integrity while accommodating its unique spiraling terraces. Prefabricated components were brought to the site and assembled with millimeter precision, reducing construction time and waste. To ensure stability, engineers implemented an advanced core and outrigger system, which provides resistance against wind forces and seismic activity. The building also features rainwater collection systems integrated into the terraces, enabling irrigation for the lush greenery. The Spiral incorporates cutting-edge sustainable technologies. Its green terraces improve air quality and reduce urban heat, while smart systems monitor and optimize energy use in real time. The building also includes advanced HVAC systems and water-efficient plumbing, reducing its environmental footprint.
We have to travel to Chicago for the next megaproject. The Chicago Deep Tunnel Project, formerly known as the Tunnel and Reservoir Plan, is an ambitious civil engineering project designed to address the critical issues of urban flooding and water pollution in the city. Spanning over 100 miles of deep, large-diameter tunnels located up to 300 feet beneath the city, the Deep Tunnel Project is one of the largest and most comprehensive urban water projects in the world. With a total estimated cost projected at $3 billion, one of the primary functions of the tunnel is to capture and store stormwater runoff and sewage that would otherwise overflow into the city's rivers and Lake Michigan during heavy rain events. This system can hold up to 2.3 billion gallons of stormwater, significantly reducing the frequency and severity of water pollution incidents and urban flooding in the region. The construction of the Deep Tunnel Project has been a monumental undertaking. It required the use of massive tunnel boring, Machines, some of the largest in the world, which have carved out tunnels with diameters ranging from 9 to 33 feet. One of the distinguishing features of the project is the construction of 3 immense reservoirs designed to work in conjunction with the tunnels. The largest of these, the Thornton Composite Reservoir, was completed in 2015 and covers 300 acres, making it one of the largest man-made reservoirs for stormwater management in the world. Its capacity is so vast that it could theoretically hold all the water used to fill over 2,000 Olympic-sized swimming pools. In comparison to other megaprojects, such as the Boston Big Dig or the London Sewer System Upgrade, the Chicago Deep Tunnel project stands out for its scale and its focus on water management in a densely populated urban setting. Next up, it's time to travel to New York for the Bayonne Bridge raising project. This development is an extraordinary engineering feat located over the Kill-Van-Kull Strait, connecting Staten Island, New York to Bayonne, New Jersey. This project was initiated to address the critical need for modern cargo ships to access the ports of Newark and Elizabeth, New Jersey, which are among the busiest on the eastern seaboard. The original bridge, completed in 1931, had a navigational clearance that was too low for the new generation of ultra-large container vessels introduced with the expansion of the Panama Canal. Completed in 2019, the project successfully raised the bridge's roadway from 151 feet to 215 feet above the water level, while also maintaining the iconic arch design. This adjustment made it possible for ships nearly twice the size of those previously accommodated to pass underneath, significantly increasing the operational capacity and efficiency of the port facilities. The project cost was approximately $1.7 billion, reflecting both its scale and complexity. One of the significant challenges was executing the work without disrupting the heavy vehicular traffic on the bridge, which necessitated innovative construction methods and careful scheduling. In terms of its engineering methodology, the project was notable for its use of the raise the roadway technique. This method involved building a new roadway above the existing one while traffic continued below, and then removing the lower roadway upon completion. Comparing the scale of the Bayonne Bridge project to other engineering projects, its new 215-foot clearance is high enough to accommodate an NFL football field standing on end. The Bayonne Bridge raising faced numerous challenges during its execution, including technical difficulties inherent in working with existing structures, the need to maintain stringent safety standards, and the unpredictable weather conditions over the strait. The project also had to navigate complex regulatory and environmental approvals, coordinating with multiple governmental bodies and community stakeholders to mitigate impacts on the surrounding areas.
Brightline West will be the first true high-speed passenger rail system in America, making a milestone in the country's transportation landscape. This modern, eco-friendly system will not only redefine train travel by connecting 2 iconic destinations, Las Vegas and Southern California, but it'll also bring the U.S. up to speed with international high-speed rail standards, popular in regions like Europe and Asia. The project aims to provide a faster, greener, and more efficient alternative to driving or flying, with trains reaching impressive speeds of up to 200 miles per hour. This 218-mile passenger rail service will stretch from Las Vegas to Rancho Cucamonga, California, with 96% of its alignment within the median of the I-15 highway. This strategic placement minimizes land use impact and maximizes direct travel, allowing passengers to enjoy a seamless journey with scenic views along the route. Today, nearly 50 million annual trips occur between Los Angeles and Las Vegas, over 85% of them by car, making the drive a long, unpredictable trip, often plagued by heavy congestion, road delays, and high fuel costs. By replacing these car trips with fast, reliable train service, Brightline West expects to serve more than 9 million one-way passengers annually. This shift is projected to reduce traffic congestion significantly and lower greenhouse gas emissions, offering a sustainable alternative for the busy 270-mile journey and helping the region meet its climate action goals. The first phase of Brightline's West service is expected to begin by 2028, drastically reducing travel time between Las Vegas and Rancho Cucamonga in just about 2 hours and 10 minutes. This efficiency will allow travelers to bypass both the unpredictable road conditions and the time-consuming process of air travel, which includes check-in and security waits. The rail journey will be smooth, relaxing, and importantly, eco-friendly. This high-speed rail project is part of a broader push in the US to modernize its aging transportation infrastructure, with an emphasis on sustainable options. As a fully electric rail system, Brightline West will be powered by renewable energy sources, aligning with California's ambitious clean energy and emissions reduction goals. Furthermore, the Rancho Cucamonga station will integrate seamlessly with local transit, including Metrolink, allowing passengers quick access to the greater Los Angeles area, creating a more connected, transit-oriented future. Once completed, the Brightline West is expected to set a new standard for high-speed rail travel in the US, demonstrating the potential of sustainable, high-speed transit to transform the regional connectivity, reduce travel times, and offer a viable alternative to cars and planes for millions of travelers each year. This pioneering project could serve as a model for other high-speed rail developments across the country, igniting a movement toward cleaner, faster, and more efficient transportation for generations to come.
Next, we have to talk about the incredible Central Park Tower, soaring 1,550 feet above New York City. This tower holds the title of the tallest residential building in the world. Located on Billionaires Row along West 57th Street, this architectural marvel represents luxury and engineering mastery. Completed in 2020, it redefines urban living while contributing to the iconic Manhattan skyline. Its construction began in 2014 with the goal of combining cutting-edge engineering with luxury. The prime location of the tower offers unparalleled views of Central Park and beyond, making it a coveted address for the world's elite. With a total cost of approximately $3 billion, the building houses 179 ultra-luxurious residences, including a triplex penthouse, along with premium commercial spaces. Residents enjoy access to the Central Park Club, a 3-story private club featuring a ballroom, outdoor terrace, and a 60-foot swimming pool. Other amenities include a state-of-the-art fitness center, private dining spaces, and unparalleled views of Central Park. While luxury is its hallmark, Central Park Tower incorporates sustainable features. High-performance glass reduces energy consumption by optimizing natural light while minimizing heat gain. Efficient HVAC systems and LED lighting further enhance energy efficiency. Central Park Tower stands 98 stories tall with a unique cantilever design that extends over neighboring structures to maximize views. The exterior features a sleek curtain wall facade made of reflective glass and stainless steel, enhancing its modern aesthetic. The structure employs a concrete and steel core to ensure stability and withstand high wind pressures, a necessity for super tall skyscrapers. Advanced damping systems minimize swaying, ensuring comfort for residents on higher floors. The interiors of the tower reflect sophistication, with premium materials like marble, custom woodwork, and high-end fixtures. Residents also enjoy exclusive amenities spread across 5,000 square feet, including a private club, fitness center, spa, and a 60-foot indoor pool. Building a skyscraper of this scale poses significant challenges, including navigating strict zoning regulations in New York and coordinating complex logistics in a densely populated area. Modular construction techniques and a high-strength concrete mix were employed to expedite the process. Workers meticulously assembled the cantilevered sections of the building to ensure structural integrity without compromising aesthetic appeal.
Let's delve into the Northgate Link extension, a transformative addition to Seattle's public transportation network. Completed at a cost of $1.9 billion, this project is a cornerstone of the region's efforts to enhance urban mobility and reduce traffic congestion. Breaking ground in 2012 and opening to the public in October 2021, the Northgate Link extension stretches the city's light rail system by 4.3 miles, connecting the University of Washington to Northgate. This crucial extension includes 3 new stations, strategically located to serve key residential and commercial hubs in northern Seattle. A defining feature of the Northgate Link extension is the engineering marvel of its twin tunnels, constructed using state-of-the-art tunnel boring machines. These machines, dubbed Brenda and Pamela, excavated deep beneath the city, navigating complex soil conditions and existing underground infrastructure with remarkable precision. The construction process engaged thousands of workers and required intricate planning and coordination. Each new station is designed with a focus on accessibility, safety, and community integration, featuring modern amenities and public art installations that enhance the commuter experience. The Northgate Link extension significantly reduces travel times, with the journey from Northgate to downtown Seattle now taking just 14 minutes. This improvement is expected to ease road traffic and provide a reliable alternative to driving, fostering greater use of public transportation. The project's impact on Seattle's urban landscape is profound, revitalizing neighborhoods and stimulating economic growth around the new stations. Let's investigate the Gran Gasoducto del Sur next. This is a major infrastructure project designed to transport natural gas from Venezuela to Argentina, passing through Brazil. This ambitious project aims to enhance regional energy integration and provide a reliable supply of natural gas to support economic growth and development in South America. Construction of the Gran Gasoducto del Sur began in 2015, with the project expected to span approximately 5,000 miles. The pipeline is designed to transport up to 50 million cubic meters of natural gas per day, providing a crucial energy source for industrial, commercial, and residential use. The pipeline will connect key natural gas fields in Venezuela with major consumption centers in Brazil and Argentina, enhancing energy security and reducing reliance on imported fuels. One of the significant engineering challenges of the Gran Gasoducto del Sur is the diverse terrain it traverses. The pipeline route includes dense forests, mountainous regions, and river crossings, requiring advanced engineering solutions and extensive environmental assessments. The project incorporates state-of-the-art technology for pipeline construction and monitoring, ensuring the safety and reliability of the gas supply. The total cost of the Gran Gasoducto del Sur is estimated at $23 billion. The project is expected to generate substantial economic benefits, including job creation, increased energy supply, and enhanced regional cooperation. Environmental and social considerations are integral to the Gran Gasoducto del Sur project. Comprehensive environmental impact assessments were conducted to minimize the impact on local ecosystems and communities. The project includes measures to protect biodiversity, manage water resources, and engage with local communities to address their concerns and ensure their participation in the project's benefits. We have to travel over to Sao Paulo, one of the largest and most populous cities in Brazil. They are enhancing its public transportation infrastructure with the Sao Paulo Metro Line 6. Often referred to as the Orange Line, this project aims to alleviate the chronic traffic congestion in the metropolitan area. Spanning approximately 15 miles, Line 6 will connect the northwest region of Sao Paulo with the downtown area, providing a crucial link for daily commuters. Construction of the Sao Paulo Metro Line 6 commenced in 2015, but faced several delays due to financial and administrative challenges. However, the project gained momentum in recent years, with a renewed commitment to completing this vital infrastructure. The line will include 15 stations, each designed to accommodate a significant number of passengers with modern facilities and accessibility features. The stations are strategically located to serve densely populated neighborhoods, universities, and commercial areas, enhancing the overall connectivity of the city's metro network. One of the significant engineering feats of this project involves the use of tunnel boring machines to excavate the tunnels. These machines, known for their precision and efficiency, are capable of drilling through various soil types found in Sao Paulo. The machines also help minimize surface disruption, a critical factor in a bustling city. The tunnels are reinforced with precast concrete segments, ensuring their structural integrity and longevity. The expected daily ridership of the Sao Paulo Metro Line 6 is projected to exceed 600,000 passengers, significantly reducing the number of vehicles on the road and thereby decreasing traffic congestion and pollution. The integration of this line with other metro lines and bus networks will provide seamless transit options for millions of residents and visitors. The project's budget is estimated at approximately $3 billion, reflecting its scale and complexity. The successful completion of Line 6 is anticipated to not only improve transportation efficiency, but also boost the local economy by creating jobs. Next,
The Los Angeles International Airport modernization is one of the most exciting projects currently underway. Known for its innovation, California is now pushing the limits of air travel infrastructure, and LAX is at the heart of it. If you've ever flown through LAX, you know the frustrations: traffic jams, endless lines, and overcrowded terminals. But all that is about to change. 75 million passengers traveled through LAX in 2023. The $30 billion overhaul of one of the busiest airports in the world aims to give travelers a smoother, faster, and more enjoyable experience. One of the standout features of this project is the introduction of the automated people mover. Imagine a stress-free way to get around the airport. No more long walks or frustrating shuttle buses. The APM will connect 6 stations along a 2.25-mile route. This $2.25 billion project is set to open in January 2026, and it will revolutionize how people move through LAX. But that's just the beginning. The Tom Bradley International Terminal at LAX is getting a massive makeover, a 500,000 square foot expansion with 17 new international gates. That's exactly what LAX delivered with its Bradley West gates. The existing 300,000 square feet of the terminal are being renovated 24/7. This means advanced baggage handling, customs concessions, and even VIP lounges. And let's not forget the Delta Skyway, a joint $2.3 billion project between LAX and Delta Airlines. Opened in phases, this state-of-the-art facility connects Terminals 2 and 3, offering 27 gates and over 1 million square feet of modern amenities. Imagine breezing through security with new lanes and self-service kiosks, or relaxing in the luxurious Delta Sky Club, enjoying panoramic views of the city. With the Skyway, you can forget about shuttle buses and enjoy seamless connections between terminals. Looking ahead to 2028, Terminal 9 is set to revolutionize international travel. This new terminal will include 12 to 18 gates, full-service international capabilities, and direct access to the APM, coupled with expanded taxiways and runways. LAX will be ready to handle more flights and accommodate the latest aircraft. What makes this entire project even more fascinating is the engineering technologies being employed. The use of digital twin technology is particularly impressive. A digital replica of the airport helps engineers and contractors visualize and simulate construction phases in real time. This allows them to identify and solve potential issues before they arise, speeding up construction and minimizing disruptions to ongoing airport operations. The digital twin integrates 3D models with project schedules, ensuring that everything runs smoothly despite the massive scale of the project. The inline baggage handling and screening system is another feature. This $613 million investment automates baggage screening across all 9 terminals, making it faster and safer for passengers. LAX is not just upgrading its infrastructure, it's setting new industry standards for efficiency and security. Let's talk about the midfield satellite concourse in South now. This expansion will add approximately 150,000 square feet and 8 gates for narrow-body aircraft to the west gates at Tom Bradley International Terminal. The LAX modernization project isn't just about improving air travel. It's a significant economic driver. This project is expected to create over 121,000 construction jobs annually, making it a win-win for both travelers and the community.
Let's delve into the monumental Grand Coulee Dam project, an iconic feat of engineering located on the Columbia River in Washington state. Completed in 1942, this project was a cornerstone of the New Deal, aimed at combating the economic woes of the Great Depression while harnessing the power of the mighty Columbia River. With a final price tag of $168 million, it was one of the most expensive and ambitious infrastructure projects of its time. Construction of the Grand Coulee Dam began in 1933 and required the collective effort of over 12,000 workers at its peak. These workers faced numerous challenges, including harsh weather conditions and the logistical complexities of managing such a vast construction site. The dam stretches 523 feet across and stands 550 feet tall, making it the largest concrete structure in the United States. Its creation transformed the region, providing vital hydroelectric power and irrigation that would spur agricultural and economic development. One of the most impressive aspects of the Grand Coulee Dam is its hydroelectric power capacity. Initially, it housed 3 power plants with a total generating capacity of 2280 megawatts. Over the years, expansions have increased this capacity to over 6,800 megawatts, making it one of the largest power producers in the world. The dam also created Lake Roosevelt, a reservoir that spans approximately 125 square miles. This reservoir provides irrigation to over 600,000 acres of farmland, transforming arid regions into fertile agricultural lands. The agricultural productivity of central Washington owes much to the water resources provided by the Grand Coulee Dam. However, the construction of the dam was not without its controversies and challenges. It necessitated the relocation of thousands of people and had significant environmental impacts, particularly on fish populations and the livelihoods of indigenous tribes. The project's success required innovative engineering solutions, such as the use of massive cableways to transport concrete and materials across the site and careful management of the Columbia River's flow. It's time to talk about the Aqui Superport, located in São João da Barra, Brazil. This deep water port is designed to handle a wide range of cargo, including oil, iron ore, and containerized goods, providing a critical gateway for Brazil's exports and imports. Construction of the Aqui Superport began in 2007, and the project was completed in phases, with full operational capacity achieved in 2015. The port complex covers an area of approximately 130 square miles and features multiple terminals, including a dedicated oil terminal, an iron ore terminal, and a container terminal. The port's deep water berths can accommodate some of the largest vessels in the world, including very large crude carriers and Capesize bulk carriers. One of the significant engineering challenges of the Aqui Superport project was the construction of the port's extensive infrastructure. This included the dredging of deep water channels, the construction of breakwaters, and the development of onshore facilities such as storage tanks and conveyor systems. The project also involved the installation of advanced navigation and safety systems to ensure the safe and efficient movement of vessels. The price tag of this immense undertaking is $2.5 billion. The port has generated significant economic benefits, including increased trade, job creation, and the development of associated industries such as logistics and manufacturing. Let's move over to the next megaproject. Spanning the Hudson River in New York, the Governor Mario M. Cuomo Bridge is a stunning feat of engineering that has reshaped the transportation landscape between Rockland and Westchester counties. Completed in 2018, this impressive structure replaced the aging Tappan Zee Bridge. The project, named after the late New York governor, represents a monumental investment in infrastructure, with a total cost of approximately $4 billion. Constructed over 5 years, the project faced numerous challenges, including maintaining traffic flow on the existing bridge while the new spans were being built parallel to it. The project utilized advanced construction techniques such as floating cranes, one of the largest in the world, known as the I-Lift New York Super Crane, which lifted and placed sections weighing up to 1,200 tons. The bridge stretches approximately 3 miles in length, with each of the twin spans measuring around 1,200 feet at their longest span. These spans are supported by 8 419-foot towers, which are angled outwardly, a design choice that not only provides structural efficiency, but also gives the bridge its visually striking profile. One of the unique aspects of the Cuomo Bridge is its accommodation for various transportation modes. It includes not only 8 traffic lanes, but also a shared-use path for bicycles and pedestrians, featuring 6 scenic overlooks and art installations. In terms of materials, the bridge incorporates more than 220 million pounds of American-made steel and 300,000 cubic yards of concrete. To put the size of the project into perspective, the amount of cable used in the bridge's stay cables could stretch from New York City to Chicago if laid end-to-end. Special features of the bridge include its resilience to extreme weather conditions, designed to withstand the increasing frequency of severe weather events. It is built with corrosion-resistant steel and concrete to ensure a lifespan of over 100 years, significantly improving on the durability of its predecessor. It's time to travel to the state of Texas, where Tesla's Gigafactory is located. This sprawling facility, initiated in July 2020, underscores Tesla's commitment to scaling up its production capabilities, particularly for the Tesla Cybertruck, Model Y, Model 3, and Tesla Semi. Occupying over 2,500 acres along the Colorado River, Giga Texas is designed to be an eco-friendly facility, integrating closely with the surrounding environment. The site is one of the largest buildings in the world by footprint, featuring approximately 10 million square feet of operational space spread over several floors. This size equates to about 172 football fields, providing a visual of the vast scale of this project. The total investment by Tesla into this project is expected to exceed $1 billion, which is anticipated to inject significant economic activity into the local and state economy through direct employment and ancillary benefits to suppliers and service providers. Gigantescos is pivotal in solving the logistical challenges associated with Tesla's supply chain, aimed at reducing shipping costs and production bottlenecks. It is set to become a critical hub for Tesla's operations in the eastern United States, enhancing the company's distribution logistics across the East Coast and international markets. The factory's location was strategically chosen for its proximity to rail and road networks, facilitating efficient material shipments and distribution of finished vehicles. Next up, let's delve into the monumental Houston Metrorail expansion project, a $7.5 billion undertaking that aims to revolutionize public transit in Houston, Texas. Spanning an impressive 20 miles of additional track, the Metrorail expansion is designed to connect more neighborhoods and increase accessibility across the city. The project involves intricate construction phases, which began in earnest in 2021 and are scheduled to reach completion by 2028. Over the course of these 7 years, the landscape of Houston will see transformative changes. Houston's flat and expansive geography presents unique challenges. Engineers are continuously combating the city's soft soil, which is prone to shifting and sinking. This has led to the innovative use of deep concrete pilings and reinforced steel to ensure the stability of tracks and stations. The project also incorporates elevated sections and raised platforms, designed to withstand Houston's frequent floods, thereby safeguarding the transit system's operational integrity during severe weather conditions. Each new station along the expansion route is being built with more than functionality in mind. They are envisioned as community hubs, equipped with modern amenities, real-time travel information, and artwork reflective of local culture. Despite the benefits, the path hasn't been entirely smooth. Issues ranging from logistical challenges, such as coordinating with existing traffic and utility lines, to public opposition concerning construction disruptions, have tested the project's resilience. The project management team has had to innovate on the fly, employing cutting-edge construction techniques and real-time problem-solving to keep the project on track. Specialized construction methods like the use of silent piling technology to minimize noise in residential areas and the application of advanced GPS and GIS for precision in layout and execution highlight the technical sophistication of this expansion. Next up, it's time to move over to the country of Uruguay, where the Punta del Tiger power plant stands. This natural gas-fired power plant is one of the largest in Uruguay, with a total generating capacity of 530 megawatts. Construction of the Punta del Tiger power plant began in 2013 and was completed in 2017. The project was implemented in 2 phases, with the first phase involving the construction of a 200-megawatt combined cycle unit, and the second phase adding an additional 330-megawatt unit. The plant utilizes state-of-the-art technology to ensure high efficiency and low emissions, contributing to Uruguay's efforts to reduce its carbon footprint. One of the key features of the Punta del Tiger power plant is its flexibility. The plant can operate on both natural gas and diesel, providing a reliable energy source even in the event of disruptions to natural gas supply. This dual-fuel capability enhances the plant's operational flexibility and energy security. The project faced several challenges, including the need to secure financing and manage environmental and social impacts. The total cost of the Punta del Tiger power plant was approximately $800 million. The project created numerous jobs during the construction phase and continues to provide employment opportunities in the operation and maintenance of the plant. Environmental considerations were integral to the project. The plant incorporates advanced emissions control technologies to minimize its environmental impact, and comprehensive environmental assessments were conducted to ensure compliance with local and international standards. The Punta del Tiger power plant plays a crucial role in Uruguay's energy landscape, providing a reliable and flexible energy source that supports the country's economic growth and development. Next, let's explore the Las Vegas Convention Center expansion. With a total investment of $4.3 billion, this expansion project significantly enhances the capabilities and allure of one of the world's largest convention centers. Officially completed in 2021, the Las Vegas Convention Center expansion spans 1.4 million square feet, adding substantial new space to the existing facility. The project includes the new West Hall, which alone provides an additional 600,000 square feet of exhibit space, complemented by a stunning 14,000 square foot outdoor terrace offering breathtaking views of the Las Vegas Strip. One of the most innovative aspects of the expansion is the integration of the LVCC Loop, an underground transportation system developed by Elon Musk's The Boring Company. This system features autonomous electric vehicles that transport attendees between the convention center's different halls at high speeds, significantly reducing transit times across the vast complex. The expansion was driven by the growing demand for large-scale event spaces in Las Vegas, which hosts numerous high-profile conventions, trade shows, and corporate events annually. Construction of the expansion required the coordination of thousands of workers and the use of cutting-edge building techniques to ensure that the project met its ambitious goals on time and within budget. Despite the challenges posed by the pandemic, the project team implemented rigorous health and safety protocols to keep the work on track. Sustainability was also a key focus of the expansion, with the new West Hall designed to achieve LEED certification for its environmentally friendly features. These include energy-efficient lighting, water-saving fixtures, and the use of sustainable materials throughout the construction process. In addition to the increased exhibit space, the expansion features advanced technological infrastructure, including high-speed internet and state-of-the-art audiovisual capabilities to meet the needs of modern events and exhibitions.
Next up, we have to talk about an $8 billion plan to save LaGuardia Airport, one of the largest airport reconstruction projects in history. Once criticized for its outdated infrastructure and passenger experience, LaGuardia is now undergoing a complete transformation. This modernization project involves constructing entirely new terminals, upgrading runways, and improving accessibility. The key components include a state-of-the-art Terminal B, a new Terminal C for Delta Airlines, and a central arrivals and departures hall that connects all terminals seamlessly. The state-of-the-art facility at LaGuardia will span 1.3 million square feet, featuring 37 gates across 4 concourses. There's also a direct-to-security luggage drop-off option. Passengers will enjoy security features, improved transportation access, additional taxiways to reduce delays, iconic public art, gourmet food offerings, and more. The restrooms have corridors behind them, so janitors can empty the trash without disturbing customers. The entrances have mosaic murals representing different parts of New York City. One of the standout features of the terminal is its aquagraphic water curtains integrated into the design of the terminal. These curtains, located on the 4th level of the arrivals and departures hall, create a mesmerizing visual experience by using 450 solenoid valves, manipulating water into precise, figurative, and abstract forms. The water ballet is synchronized with light projections and video displays, turning the airport into an artistic space for travelers. The project involves demolishing existing structures and replacing them with state-of-the-art terminals, such as the newly completed Terminal B. Modular construction methods have been used to minimize disruptions to airport operations. The new terminals feature large-span steel trusses, allowing for open, airy interiors without compromising structural integrity. A signature pedestrian bridge connecting Terminal B to 2 concourses was built using prefabricated sections. Modern baggage handling systems and smart technology have been integrated to improve efficiency and reduce wait times. The project also includes enhanced transportation links to and from the airport. The improved connections to the New York City subway system and a dedicated bus terminal make LaGuardia more accessible to travelers across the city. The new design will also focus on sustainability, with the integration of energy-efficient systems and eco-friendly materials throughout the airport. The renovation will add state-of-the-art security features, expanded concourses, and more comfortable seating areas for travelers. The new LaGuardia will be able to handle 30 million passengers annually by 2025.
But what about the construction of a massive train station? Denver Union Station was reopened in 2014 after a comprehensive $540 million redevelopment, and the historic train station has been reimagined into a vibrant, multimodal hub that anchors Denver's thriving transit-oriented development. Originally constructed in 1881, Denver Union Station had fallen into disrepair and underutilization by the late 20th century. The bold revitalization project, which began in earnest in 2010, was spearheaded by a public-private partnership aiming to revitalize the area while preserving its historic charm. The project covered 19.5 acres and involved the integration of light rail, Amtrak, buses, and new pedestrian and bicycle pathways, creating a nexus of connectivity for the city and the region. One of the most compelling aspects of the Union Station project was the creation of an underground bus concourse. This 22-gate facility spans nearly 1,000 feet in length roughly, the length of 3 football fields situated beneath 1.5 acres of public plaza that includes fountains and space for public events. This innovative design successfully separates bus traffic from pedestrian areas, enhancing safety and urban aesthetic. The station itself houses more than 110,000 square feet of mixed-use development, including retail shops, restaurants, and a hotel, which occupy the historic terminal building. The Denver Union Station project's challenge was to integrate seamlessly into the existing urban fabric, preserving historical elements like the station's iconic travel by train neon sign while introducing cutting-edge infrastructure. Moreover, the project team faced the complex task of coordinating multiple transportation systems in a tight urban core, all while maintaining service for thousands of daily commuters. The economic impact has been profound, with billions of dollars in private investment flowing into the surrounding area since the station's reopening. Next up, we have to talk about the Atlanta Beltline project. Envisioned as a comprehensive revitalization effort, the Beltline aims to convert a historic 22-mile railroad corridor encircling downtown Atlanta into a multi-use trail, modern streetcar line, and expansive green space. This grand project, which began in the early 2000s and is expected to continue in phases through 2030, is not only redefining urban transit, but also enhancing community connectivity. With an estimated cost exceeding $4.8 billion, the Atlanta Beltline is one of the largest, most wide-ranging urban redevelopment projects in the United States. It involves the coordination of multiple city departments and private contractors, engaging thousands of workers over its multiple phases of development. The Beltline addresses several critical urban challenges, including the need for improved public transportation options. By connecting 45 in-town neighborhoods with multi-use trails and transit options, it promotes a more sustainable lifestyle, reducing reliance on automobiles and encouraging walking, biking, and public transit. A notable feature of the Atlanta Beltline is its use of existing railroad tracks for the trail and transit system. The incorporation of art installations in parks along the Beltline has also turned previously neglected spaces into vibrant public areas that foster community interaction and cultural expression. The project has faced challenges, particularly in terms of funding and community engagement. Balancing the diverse needs and expectations of various stakeholders, residents, and city officials has required continuous dialogue and adaptation.
We can't overlook the massive Klamath River project. With a price tag of $450 million, this project involves removing 4 hydroelectric dams to restore natural fish migration patterns and improve water quality. For over a century, these dams have blocked vital fish habitats, and the removal is set to be completed by the end of 2024. This will open up 400 miles of river for species like Chinook salmon and steelhead trout. Let's dive into the engineering behind this transformative project. The 4 dams planned for removal are known as the Lower Klamath Project. They include the J.C. Boyle, Copco No. 1, Copco No. 2, and Iron Gate dams. These dams were originally built for hydroelectric power generation, but they've also severely disrupted natural water flow and fish migration for decades. So how do you remove dams that stood for a century? At J.C. Boyle Dam, an existing drain that was originally built to divert water during the construction of the dam will be used to drain the reservoir. Concrete step logs currently blocking this drain will be blasted open to allow the water to flow through. Once the reservoir is drained, workers will begin demolishing the dam structure itself. Meanwhile, at Copco No. 1, engineers will drill a new tunnel through the base of the dam. This tunnel will act as a controlled release point for water. The demolition crews will use drilling and blasting techniques to dismantle Copco No. 2 and Iron Gate Dam. The goal of this project isn't just about removing dams, it's about restoring an entire ecosystem. The Klamath River project is the largest dam removal project in U.S. history. It's part of a growing movement to rethink how we manage natural resources, prioritizing ecosystem health and sustainability over industrial infrastructure. Projects like this set a powerful example for future ecological restoration efforts. Over 76,000 cubic meters of concrete and 2,000 tons of steel will be removed. Nearly 1 million cubic meters of material will be excavated to return the river to its natural state.
We have to travel over to Peru now for the Chinchero International Airport construction project. Located near Cusco, it's a major infrastructure project designed to enhance the region's connectivity and support the growing tourism industry. Cusco is the gateway to Machu Picchu, one of the world's most popular tourist destinations, and the new airport aims to accommodate the increasing number of visitors while alleviating congestion at the existing Alejandro Velasco Estide International Airport. Construction of the Chinchero International Airport began in 2018, with the project expected to be completed by 2025. The airport will feature a modern terminal building, a 13,000-foot runway, and state-of-the-art navigation and communication systems. The terminal will be designed to handle up to 5 million passengers annually, providing a significant boost to the region's tourism infrastructure. One of the key engineering challenges of the Chinchero International Airport project is its location at an altitude of approximately 12,500 feet above sea level. The high-altitude environment presents unique challenges for aircraft performance and passenger comfort, requiring specialized design and operational considerations. The project also involves extensive earthworks and site preparation to ensure the stability and safety of the airport infrastructure. The total cost of the Chinchero International Airport project is estimated at $500 million, funded by the Peruvian government and international investors. The project is expected to generate significant economic benefits, including job creation during the construction phase and increased tourism revenue once the airport is operational. But how about a massive interstate megaproject? In the heart of Texas, the North Tarrant Express project stands as a testament to transformative infrastructure innovation. Initiated in 2010 and completed in 2014, this project revolutionized 13.3 miles of Northeast Loop 820, an airport freeway designed to address the burgeoning needs of one of the fastest-growing regions in the United States. The project, costing approximately $2.1 billion, wasn't just about expansion. It was about reimagining mobility. By incorporating managed toll lanes known as Texpress lanes, the North Tarrant Express introduced dynamic pricing to manage traffic flow, a first of its kind in Texas. These lanes adjust prices based on real-time traffic conditions, optimizing roadway usage and drastically reducing congestion. Traditional road expansions of this magnitude typically span decades, yet this project compressed timelines into a mere 4 years of construction, all while keeping the highway open. This feat was achieved through around-the-clock work and an innovative approach to staging and materials handling that minimized disruptions to the daily lives of nearly 200,000 drivers. This immense undertaking required the coordination of thousands of workers, from engineers who redesigned interchanges to support smoother traffic flow to expansive construction teams. The North Tarrant Express implemented several green initiatives, such as using recycled materials for roadbeds and deploying advanced stormwater management systems to protect the region's waterways, setting a new standard for eco-friendly construction practices in large-scale infrastructure projects. Moreover, the economic impact of the North Tarrant Express has been profound. By improving access and reducing travel times, the project has spurred growth in local communities, enhanced property values, and attracted new businesses looking to capitalize on improved logistics and accessibility. Next, let's examine the New Orleans Flood Protection System, a monumental infrastructure project designed to safeguard the city from devastating floods. This extensive system, with a staggering investment of $14.5 billion, stands as a critical response to the catastrophic impact of Hurricane Katrina in 2005. The system encompasses a complex network of levees, floodwalls, pump stations, and surge barriers designed to withstand a 100-year storm event. A key component of the system is the Inner Harbor Navigation Canal Surge Barrier, one of the largest civil works projects in the United States. This massive barrier stretches nearly 2 miles and features a series of gates and pumps that can be activated to block storm surges from entering the city. The I-Inc surge barrier alone cost $1.1 billion and plays a vital role in protecting New Orleans from potential flooding. Another significant element is the Lake Borgne surge barrier, which extends for 1.8 miles and is designed to prevent storm surge from entering the Gulf Intracoastal Waterway and the Mississippi River Gulf Outlet. This barrier, coupled with numerous floodwalls and levee improvements, forms a robust defense against rising waters. The construction of the flood protection system was a massive undertaking involving tens of thousands of workers and extensive coordination between federal, state, and local agencies. The project faced numerous challenges, including the technical difficulties of working in a region characterized by soft, shifting soils and the need to protect the unique ecosystems of the Louisiana wetlands. In addition to physical barriers, the system incorporates advanced pump stations capable of removing vast amounts of water from the city's drainage canals. These pumps are essential for managing heavy rainfall and preventing water from accumulating in low-lying areas, which are particularly vulnerable to flooding.
Let's move over to the One Vanderbilt, which was completed in 2020 and redefined the New York City skyline as a towering example of engineering brilliance. Located adjacent to Grand Central Terminal, this $3.3 billion skyscraper is a symbol of innovation and sustainability, merging functionality with breathtaking design. The project was conceived in 2010 as part of Midtown East's rezoning plan, aimed at revitalizing the area. Construction began in 2016, with the goal of creating a state-of-the-art commercial hub that integrates seamlessly with public transit systems. One Vanderbilt stands at 1,401 feet, making it the fourth tallest building in New York City. It offers 1.7 million square feet of office space spread over 58 stories, designed to accommodate thousands of workers. The tower features Summit One Vanderbilt, an immersive observation deck at 10 × feet, providing panoramic views of the city. Advanced elevator systems reduce wait times, enhancing efficiency. The construction of One Vanderbilt presented significant challenges due to its proximity to Grand Central Terminal. Engineers had to ensure the tower's foundation did not disrupt the historic infrastructure beneath. To achieve this, they used drilled caissons to transfer the building's weight deep into the bedrock, ensuring stability. The structure incorporates a steel and concrete hybrid frame, providing the strength needed to withstand wind forces at such heights. Engineers also designed the building with tapered setbacks, reducing wind loads and giving the tower its iconic shape. A tuned mass damper, weighing hundreds of tons, is installed near the top to counteract swaying and enhance comfort for occupants. Modular construction accelerated timelines while maintaining quality. Its glass curtain wall facade minimizes heat gain while maximizing natural light, contributing to energy efficiency. Integration with Grand Central Terminal involved building a direct transit connection, allowing seamless access to subway and commuter trains. This made One Vanderbilt a central transit-oriented development. The $3.3 billion project not only transformed Midtown Manhattan, but also generated thousands of construction jobs.
But what about a massive dam megaproject? For that, we have to travel to the Ohio River, where the Olmsted Locks and Dam project is located. This monumental undertaking, designed to replace aging infrastructure and modernize the waterway system, is crucial for the transportation of billions of dollars worth of goods annually across Central States. This project, which officially completed in 2018 after over 30 years of planning and construction, spans across the river and involved an extraordinary financial investment of approximately $3 billion. The construction required the sustained effort of hundreds of engineers, technicians, and laborers over several decades, underscoring the project's scale and complexity. The Olmsted project replaced two older and less efficient facilities, locks and dams 52 and 53, which had become increasingly unreliable, causing significant delays in river traffic and logistical inefficiencies. The new structure consists of a navigational pass and two parallel 110-foot by 200-foot locks. This setup significantly eases the river traffic, allowing for the smooth passage of approximately 90 million tons of cargo yearly. One of the notable challenges of the Olmsted Locks and Dam was its innovative construction method, specifically the use of in-the-wet technology. Unlike traditional dry dock methods, this technique involves assembling large modular sections of the dam on land, then floating them to their installation site on the river. The total amount of concrete used in the dam's construction would be enough to pave a sidewalk stretching from New York to San Francisco. A special feature of the Olmsted Locks and Dam is its resilience to seismic activity. The region is near the New Madrid fault line, and as such, the structure was designed to withstand significant earthquakes, ensuring the long-term stability and safety of this critical infrastructure. The project's importance extends beyond just its immediate functionality. By improving the reliability and efficiency of the Ohio River as a navigational channel, the Olmsted Locks and Dam also bolsters the economic viability of river transportation, which is significantly more fuel efficient and environmentally friendly compared to road and rail transport.
And let's not forget about the Santa Clara Project, a massive $8 billion urban development project spanning 240 acres. It's about creating a whole new city within a city. The Santa Clara Project is set to be completed in phases, with the first phase already underway. Phase 1, known as the Tasman East Block, will feature a mix of office spaces, retail shops, and residential units, including affordable housing options. This phase alone will include 39,950 square meters of office space, 4,650 square meters of retail space, and a 480-room hotel. The underground parking garage, with a capacity of 1,900 vehicles, will also be constructed there. Following the completion of Phase 1, future phases will focus on expanding residential areas, adding more green spaces, and constructing additional office complexes. By the time the project is fully completed, it will boast over 156,000 square meters of residential space, with 170 units designated as affordable housing, along with 65,000 square meters of hotel space and 743,000 square meters of retail and restaurant space. These numbers reflect the scale and ambition of the project, which is expected to transform Santa Clara into a major urban hub. One of the most exciting aspects of the Santa Clara project is the 14.2 hectare Central Park. This expansive green space will be the heart of the community, offering residents and visitors a place to relax, exercise, and enjoy the outdoors. In addition to the Central Park, the project will feature over 10 hectares of additional open spaces. Imagine a future where your car drives itself or you commute by air taxi. The Santa Clara project is paving the way for this exciting future. That's not all though. This bustling metropolis will also feature a global food market, offering a culinary journey around the world. With a variety of retail shops, theaters, and concert spaces, Santa Clara is all set to become a cultural hub. Next,
the Governor Mario M. Cuomo Bridge, which replaced the aging Tappan Zee Bridge, is one of the most significant bridge projects in the history of New York. Costing $4 billion, this twin-span cable-stayed bridge stretches 3.1 miles across the Hudson River, connecting Rockland and Westchester counties. Completed in 2018, it represents a triumph of modern engineering and infrastructure innovation. The bridge features 2 spans, each supporting 8 lanes of traffic with a shared pedestrian and bike path, offering scenic views of the Hudson River. Its design includes sleek cable-stayed towers, which not only enhance its aesthetic appeal, but also provide structural efficiency. The lighting system incorporates energy-efficient LEDs that illuminate the bridge in vibrant colors for special occasions. Additionally, the bridge is equipped with state-of-the-art monitoring systems to ensure structural health and safety. Building the Cuomo Bridge required innovative methods to minimize environmental and community impact. Engineers employed precast concrete sections, which were manufactured off-site and transported to the construction area, reducing on-site work and improving efficiency. The foundation consists of large diameter steel piles driven deep into the riverbed to anchor the bridge securely. To accelerate the construction timeline, a custom-built floating crane nicknamed iLift NY, was used to lift massive bridge components into place. The project emphasized sustainability, incorporating durable materials to extend the bridge's lifespan to 100 years. The bridge's design reduces maintenance needs, and its LED lighting system is energy efficient. Special care was taken to protect the Hudson River's ecosystem during construction, including the creation of artificial habitats for fish. The Cuomo Bridge has improved traffic flow for 135,000 daily vehicles, reducing congestion and enhancing safety. It has also revitalized the regional economy by creating thousands of construction jobs and stimulating local businesses. The pedestrian and bike path further enhances community access and promotes eco-friendly transportation. While the bridge is celebrated as an engineering feat, it faced criticism for its high cost and project delays. Despite these challenges, it stands as a vital link for the transportation network in New York.
Let's take a closer look at the Second Midtown Tunnel project. Located under the Elizabeth River, the Second Midtown Tunnel connects the cities of Norfolk and Portsmouth. Its construction began in 2012 and reached completion in 2016. This project involved building a new two-lane tunnel parallel to the existing Midtown Tunnel, effectively doubling the capacity of this crucial traffic artery. With a cost of $2.1 billion, the construction process for the Second Midtown Tunnel was both innovative and complex. Unlike traditional tunneling methods, this project used an immersed tube technique. Prefabricated tunnel sections, each weighing approximately 16,000 tons, were constructed in a dry dock. These sections were then floated to the site, submerged into a pre-dug trench on the riverbed, and connected to form the tunnel. This method minimized disruption to river traffic and ensured precise alignment of the tunnel sections. The new tunnel not only alleviates traffic congestion, but also enhances safety and travel times for thousands of commuters. In terms of environmental considerations, the project included several measures to mitigate its impact. This included careful monitoring of water quality during construction and the use of innovative techniques to manage and minimize sediment displacement. The Second Midtown Tunnel also features modern safety enhancements, such as advanced ventilation systems, state-of-the-art lighting, and emergency response facilities. These upgrades ensure the tunnel meets contemporary standards for infrastructure resilience and commuter safety. Comparing this project to other major infrastructure endeavors, the Second Midtown Tunnel stands out for its strategic importance in regional connectivity and its use of advanced construction techniques. But what about a country that got a brand new metro system? That's what happened with the Metro de Quito project. The metro line spans approximately 14 miles and includes 15 stations, connecting the southern and northern parts of Quito. Construction of the Metro de Quito began in 2013, and the project faced numerous challenges, including the city's complex geology and the need to preserve historical sites. The metro tunnels were excavated using tunnel boring machines, which allowed for precise and efficient tunneling while minimizing surface disruption. The use of the machines also ensured the protection of Quito's colonial-era buildings and other historical landmarks. The Metro de Quito is designed to accommodate over 400,000 passengers daily, significantly reducing the number of vehicles on the road and improving air quality. The metro system features modern trains equipped with the latest technology, including automated systems for safety and efficiency. The stations are designed to be accessible and user-friendly, with features such as elevators, escalators, and clear signage. One of the significant benefits of the Metro de Quito is the reduction in travel time. Commuters can travel from one end of the city to the other in approximately 34 minutes, compared to over an hour by car during peak traffic. This improvement in mobility is expected to boost economic activities and enhance the quality of life for Quito's residents. The total cost of the Metro de Quito project is estimated at $2 billion, funded by a combination of national and international sources. The project has generated significant economic benefits, including job creation during the construction phase and increased commercial activities around the metro stations. Environmental sustainability is a key aspect of the Metro de Quito project. The metro system is powered by electricity, reducing greenhouse gas emissions and contributing to Quito's efforts to combat climate change. The project also includes measures to manage noise and vibration, ensuring minimal disruption to the surrounding communities. Next up, to talk about the construction of Raleigh Union Station. This transformative project, which officially opened its doors in July 2018, represents a major upgrade from the previous Amtrak station. Costing approximately $111.4 million, the Raleigh Union Station was meticulously designed to rejuvenate the warehouse district of downtown Raleigh, providing a multimodal hub that accommodates train, bus, and taxi services under one roof. Spanning a vast area of 26,000 square feet, the station's main building was once a dilapidated steel fabrication plant, which has been artfully transformed into a state-of-the-art facility while retaining historical architectural elements. This adaptive reuse not only preserves a piece of Raleigh's industrial heritage, but also incorporates green building practices, including a rooftop rainwater collection system that underscores the city's commitment to sustainability. The construction of Raleigh Union Station was a complex endeavor, involving numerous challenges ranging from the preservation of the existing historic structure to integrating advanced technological systems. The project team employed innovative construction methods such as seismic retrofitting to ensure the station's durability and safety, all while maintaining the integrity of the original building's rugged, industrial aesthetic. The station features lofty ceilings and a spacious concourse flooded with natural light, creating an inviting atmosphere for the approximately 160,000 passengers it serves annually. Raleigh Union Station is equipped with longer, high-level platforms that accommodate more passengers and improve the boarding process for Amtrak's Piedmont and Carolinian lines, as well as future high-speed rail services. It's time to travel to San Francisco next, where the gigantic Chase Center is one of the city's biggest megaprojects. Located in the Mission Bay neighborhood of the city, Chase Center serves as a state-of-the-art arena primarily for the Golden State Warriors and a versatile venue for concerts and other events. This mega project, completed in September 2019, was a private sector initiative spearheaded by the Warriors' ownership, costing an estimated $1.4 billion. Chase Center covers an area of 11 acres and includes an 18,000-seat arena, 2 office buildings, 100,000 square feet of retail space, and a public plaza. The project also involved the creation of a waterfront park along with a half-mile of restored public waterfront. One of the challenges in its development was integrating the center with San Francisco's existing public transport networks. This led to significant improvements in local infrastructure, including the addition of a Muni Metro light rail platform and the enhancement of nearby roads. The use of cutting-edge seismic technology was a focal point, considering San Francisco's susceptibility to earthquakes. This included innovative base isolators and shock absorbers that ensure the arena can withstand significant seismic events. Chase Center's unique architectural design and construction methods included the use of sweeping glass facades and intricate metalwork that complements the bay's maritime setting. If you consider the height of the arena at nearly 135 feet, it stands tall enough to house the Statue of Liberty inside it, giving a sense of the scale at which this construction was conceptualized and executed.
Next on our list is the remarkable California High-Speed Rail. This project seeks to connect major cities across the state with a high-speed train system. It's currently projected to cost $135 billion. The rail system could connect cities like San Francisco and Los Angeles with trains traveling up to 220 miles per hour, reaching the journey between these two cities in under 3 hours. The first stretch of this high-speed rail is set to cover 171 miles across the Central Valley. From Merced to Bakersfield, this section is a critical part of the project and is targeted for completion by 2030. Once operational, it'll offer residents in the Central Valley a fast and efficient alternative to driving while laying the groundwork for further expansion. However, since its inception in 2008, the project has faced numerous setbacks. From the start, the cost and complexity of the project were underestimated. Early estimates suggested the project would cost around $33 billion, but over time, the budget ballooned to $135 billion. Despite these challenges, progress is being made. Construction is currently underway in the Central Valley, with several segments actively being built. This region was chosen for the first phase of construction because it's relatively flat, allowing for easier development compared to more challenging terrain of urban areas like Los Angeles or San Francisco. The high-speed rail promises to be a transformative force for California, but its success will depend on navigating the financial and logistical hurdles ahead.
It's time to move over to Colombia next for the Orient Tunnel project. Designed to improve connectivity between Medellin and the José María Cordova International Airport in Riongro, this road tunnel is the longest in Colombia, spanning approximately 5.7 miles. Construction of the Túnel de Orient began in 2012 and was completed in 2019. The project involved extensive geological surveys and the use of advanced tunneling techniques to navigate the complex terrain of the Andes Mountains. The tunnel features dual bores, each accommodating 2 lanes of traffic, ensuring a smooth flow of vehicles and enhancing safety. One of the key benefits of the Túnel de Orient is the reduction in travel time. Prior to the tunnel's construction, the journey between Medellin and the airport took approximately 45 minutes to an hour, depending on traffic conditions. The tunnel reduces this travel time to just 18 minutes, providing a more direct and efficient route. The total cost of the Túnel de Orient project was approximately $300 million, funded by a combination of public and private investment. The project has generated significant economic benefits, including job creation during the construction phase and increased commercial activities once the tunnel became operational. Environmental and social considerations were integral to the project. Comprehensive environmental impact assessments were conducted to minimize the impact on local ecosystems and communities. The project also included measures to manage water resources, protect wildlife, and engage with local stakeholders to ensure that the benefits of the tunnel are shared with the surrounding areas. Next up, we have to check out the Federal Way Link extension. Located in Washington State, this significant extension aims to enhance connectivity between the densely populated regions south of Seattle, spanning from the Angle Lake Station through Des Moines and into Federal Way. The project, managed by Sound Transit, began construction in 2020 and is slated for completion later into 2024. With a budget of approximately $3.1 billion, the Federal Way Link extension will add 7.8 miles of new track to the existing light rail system, promising to significantly ease traffic congestion. Designing and constructing a light rail extension through heavily urbanized areas presents a variety of challenges. One major hurdle has been the need to integrate new rail lines with existing infrastructure, requiring complex engineering solutions to bridge roads, navigate through dense urban landscapes, and minimize disruption to local communities and ecosystems. Extensive tunneling and elevated track sections are key components of the project, designed to ensure that the rail service is both efficient and minimally invasive. The Federal Way extension will include 3 new stations that are being designed with a focus on accessibility, safety, and integration with other modes of transportation, such as buses and pedestrian pathways. The workforce behind this mega project includes hundreds of engineers, construction workers, and safety inspectors. Their expertise is essential in tackling the technical demands of modern rail construction, from laying tracks that can handle high-speed trains to installing sophisticated signaling and communication systems. Upon its completion, the Federal Way Link extension is expected to serve approximately 40,000 passengers daily by 2035. We travel over to Chile next, where the Chacao Channel Bridge is located. This project, once completed, will significantly improve transportation and economic integration between the island and the mainland. Construction of the Chacao Channel Bridge began in 2018, and the project is expected to be completed by 2025. The bridge will span approximately 1.7 miles across the Chacao Channel, featuring a central suspension span of 350 feet, making it one of the longest suspension bridges in the world. The bridge will have 2 main pylons, each rising about 656 feet above the water, supporting the central span with massive steel cables. One of the critical challenges of the Chacao Channel Bridge project is the harsh environmental conditions of the Chacao Channel. The area is known for strong winds, powerful tides, and seismic activity, all of which pose significant engineering challenges. The bridge is designed to withstand these conditions, incorporating advanced materials and construction techniques to ensure its durability and safety. The bridge will accommodate both vehicular and pedestrian traffic, with 2 lanes in each direction and dedicated pathways for pedestrians and cyclists. This infrastructure will replace the current ferry system, which is often subject to delays and weather-related disruptions, providing a more reliable and efficient transportation link. The project is estimated to cost around $740 million, with funding sourced from both the Chilean government and international investors. The economic benefits of the bridge are expected to be substantial, including increased tourism, reduced transportation costs, and enhanced economic integration between Chiloé Island and the mainland.
The California Water Fix, also known as the Delta Tunnels Project, is one of the most significant and controversial infrastructure projects in the history of California. This $17 billion plus proposal aims to modernize the water delivery system by constructing 3 massive underground tunnels in the Sacramento-San Joaquin Delta. There will also be 3 new water diversion facilities. These tunnels, each 35 miles long and 40 feet wide, are designed to protect water supplies for millions of residents in Southern California, Central Valley, and the Bay Area. The Delta is a critical water source, but it faces severe challenges due to environmental degradation, aging infrastructure, and the risk of earthquakes. This is a plan by Governor Jerry Brown to upgrade the state's aging water infrastructure and to move water in an environmentally friendly manner. The proposed tunnels will bypass the delicate ecosystem in the Delta, diverting fresh water from the Sacramento River, enhancing water supply reliability, and aiding in Delta ecosystem restoration. But there's massive controversy too. The project poses significant threats to endangered species like the Delta smelt and the winter and spring run Chinook salmon. Construction is expected to last over a decade. Once complete, the California Water Fix will provide reliable, clean, and secure water to almost 27 million Californians and 3 million acres of farmland. It'll improve environmental conditions in the Sacramento-San Joaquin Delta, alongside California Eco Restore.
Let's travel over to the Hudson Tunnel Project, a $16 billion undertaking that seeks to transform rail infrastructure between New York and New Jersey. This project is critical to modernizing the Northeast Corridor, the most heavily traveled rail line in the United States. Once completed, it will ensure seamless transit for Amtrak and New Jersey Transit passengers, improving reliability and safeguarding operations against future natural disasters. The existing North River Tunnel, built over a century ago, suffered severe damage during Superstorm Sandy in 2012. The storm left behind structural weaknesses, necessitating urgent rehabilitation. The NRT serves as the single passenger rail link between Manhattan and the western US, connecting Washington, D.C. to Boston. Without upgrades, the tunnel bottleneck risks a daily $100 million economic impact, reflecting the 20% contribution of the Northeast Corridor to the national economy. The project involves building a 2.4-mile double-track tunnel beneath the Hudson River, stretching from Bergen Palisades in New Jersey to Manhattan. Central to its scope is the rehabilitation of the North River Tunnel, addressing extensive structural and flood damage sustained over the years. Then, a concrete casing at Hudson Yards will ensure a seamless connection to Penn Station, integrating the new infrastructure into the existing rail network. To safeguard rail operations from future extreme weather events, new floodgates will be installed, providing enhanced protection against rising waters. The tunnel will incorporate state-of-the-art engineering with advanced flood resilience measures. This includes a robust drainage system, climate-resistant materials, and modern ventilation for improved air quality. The construction utilizes state-of-the-art engineering technologies to address the unique challenges of tunneling beneath a riverbed. Tunnel boring machines excavate the 2.4-mile route, ensuring precise tunneling through dense geological formations. These massive machines carve through rock and soil while simultaneously installing precast concrete tunnel linings, providing immediate structural support. Advanced geotechnical monitoring systems track ground stability in real time, minimizing risks during construction. Meanwhile, robotic systems streamline the application of waterproofing membranes, ensuring the tunnel remains impervious to leaks. Scheduled for phased completion, the new tunnel is expected to open in 2035, with the rehabilitated NRT operational by 2038. Once completed, the Hudson Tunnel project will transform rail travel, accommodating nearly 200,000 passengers daily. The project is expected to create 72,000 new jobs and $19 billion in economic activity. But this is just one of the smaller mega projects on our list.
It's time to discuss the next megaproject. Welcome to the Treasure Island redevelopment in San Francisco. Set on a man-made island in the heart of San Francisco Bay, this project is transforming a former naval base into a vibrant residential and commercial hub. Treasure Island spans approximately 405 acres. To put that into perspective, it's roughly the size of 300 football fields laid side by side. The project's budget is a whopping $6 billion, earmarked for creating over 8,000 homes, of which a quarter are designated as affordable housing. The plan includes schools, hotels, and over 300 acres of parks, which means green space is central to the island's new identity. Construction began in 2011 and is set to continue in phases through 2035. The scale of manpower and machinery on this site is staggering. At its peak, the project employed thousands of workers, each skilled in various aspects of construction, from engineers and architects to builders and landscapers, all converging to bring this vision to life. One of the most intriguing aspects of the Treasure Island redevelopment is its commitment to sustainability. The island is poised to become one of the most eco-friendly developments in the U.S. with advanced stormwater systems, zero-waste goals, and buildings designed to lead gold standards. But it hasn't been all smooth sailing. The project has faced its share of challenges, from concerns over rising sea levels to remediation of the soil, which was contaminated during its days as a naval base. These issues required innovative solutions such as elevated land to combat potential flooding and extensive cleanup efforts to ensure the safety and sustainability of the new community. The amount of soil moved and treated for the redevelopment could fill over 60 Olympic-sized swimming pools. And if we talk about the infrastructure, the main roadway spanning the island's length is akin to laying down nearly 3 Golden Gate bridges end to end. Next up,
It's time for a much taller project called 270 Park Avenue, which is soon to be the global headquarters of JP Morgan Chase. Towering 1,388 feet with 60 stories, this state-of-the-art structure redefines the workplace with cutting-edge technology, sustainability, and architectural innovation. The previous structure at 270 Park Avenue, built in the late 1950s, was designed for 3,500 employees. However, as JP Morgan Chase grew, so did its needs. The new tower, conceptualized as a timeless addition to the skyline in New York, will accommodate up to 14,000 employees. Its design celebrates iconic architecture in legacy while embracing the future of workplace environments with flexibility and collaboration at its core. The building has a state-of-the-art gym, gourmet dining, and outdoor terraces with skyline views. The project began with the demolition of the original building in 2019, marking one of the largest voluntary demolitions of a structure in history. Remarkably, 97% of the materials from the old building were recycled or upcycled, far exceeding industry standards for green building projects. The new tower is being built using a hybrid structural system of steel and reinforced concrete. This all-electric tower will be the largest in New York City with net zero operational emissions. Powered entirely by renewable energy from a New York State hydroelectric plant, the building incorporates advanced systems to ensure energy efficiency. Features include triple-pane glazing on the facade and automatic solar shades integrated with HVAC systems. These also include intelligent building technology that uses sensors and AI to optimize energy consumption. Water efficiency is another highlight, with advanced storage and reuse systems reducing water consumption by over 40%. The terraces in the building and a large public plaza offer natural green spaces, enhancing urban biodiversity and promoting well-being for workers and visitors alike. The unique structural system of the building employs fan columns and triangular bracing, enabling it to lift 80 feet off the ground. This creates an expansive open area at street level, offering 2.5 times more outdoor space along Park and Madison Avenues. Wider sidewalks and public plazas make the area more pedestrian-friendly while maintaining a seamless architectural flow.
Next up, we have to discuss one of the most expensive megaprojects in the world, called the Hanford Nuclear Reservation Cleanup. Situated in Washington state, the Hanford site was once home to the largest plutonium production facility in the United States, playing a pivotal role during World War II and the Cold War. However, decades of nuclear production have left a legacy of contamination, necessitating an extensive cleanup effort with costs estimated to range between $300 billion and $600 billion. The Hanford Nuclear Reservation spans 586 square miles and includes 9 decommissioned nuclear reactors and numerous processing facilities. The cleanup project, managed by the U.S. Department of Energy, officially began in 1989 following the site's designation as a Superfund site by the Environmental Protection Agency. One of the primary challenges of the Hanford cleanup is dealing with the vast quantities of radioactive waste stored in underground tanks. These tanks, some of which are over 70 years old, have been found to leak, posing a significant threat to the surrounding environment. A critical component of the cleanup is the construction and operation of the waste treatment and immobilization plant, also known as the vitrification plant. This facility aims to convert radioactive waste into a stable glass formed through a process known as vitrification. By immobilizing the waste in glass, the long-term risk of environmental contamination is significantly reduced. The plant is one of the most complex and expensive construction projects at Hanford, with an estimated cost of $17 billion. The cleanup efforts at Hanford also involve the remediation of contaminated soil and groundwater. Advanced technologies and methods, such as pump and treat systems, are employed to remove radioactive contaminants from groundwater and prevent their migration. The project has faced numerous challenges, including technical difficulties, regulatory hurdles, and budget constraints. Despite these challenges, significant progress has been made in reducing immediate risks and advancing long-term remediation goals. Comparatively, the Hanford cleanup is unparalleled in its scope and complexity, reflecting the immense legacy of the United States nuclear weapons program. The project's costs and duration are unprecedented, with estimates suggesting the cleanup could continue for several more decades. We move over to New York next for the Hudson Tunnel project. This massive project aims to construct a new rail tunnel under the Hudson River, directly addressing the critical need for modernized and reliable rail connections between New Jersey and Manhattan. Currently estimated to cost around $11.6 billion, the Hudson Tunnel project involves constructing a new 2-track rail tunnel, refurbishing the existing century-old tunnel, and making related infrastructure improvements. Upon completion in 2026, it is expected to significantly reduce the risk of severe disruptions in daily commutes and national rail transport. The new tunnel's construction is a complex challenge, requiring sophisticated tunnel boring and under-river drilling techniques to navigate the geological and environmental sensitivities of the Hudson River's underwater terrain. The existing North River Tunnel, which currently serves as the only rail link under the Hudson for Amtrak and New Jersey Transit trains, has been in service since 1910 and was severely damaged during Hurricane Sandy in 2012. The construction of the new tunnel will allow this old tunnel to be closed for repairs without disrupting the critical train services it provides. To understand the scale of the Hudson Tunnel project, consider that the new tunnel will extend about 2.5 miles under the riverbed, involving millions of cubic feet of excavated earth enough to fill over 1,000 Olympic-sized swimming pools. The project's challenges are immense, from navigating bureaucratic hurdles and securing funding agreements across multiple government entities to the physical difficulties of urban tunneling. We have to talk about the Northeast Boundary Tunnel next. This mammoth undertaking, part of the larger Clean Rivers project in Washington, D.C., aims to significantly reduce combined sewer overflows into the Anacostia River, enhancing the river's water quality and complying with federal clean water regulations. The project, which began in 2018, is a critical component in a series of infrastructure improvements designed to modernize the capital's century-old sewer system. Spanning 5 miles in length and located up to 160 feet below ground, the tunnel stretches from the Robert F. Kennedy Stadium to the Rhode Island Avenue NW, with a hefty price tag of approximately $580 million. The construction of the NEBT poses formidable challenges, primarily due to the complexity of drilling a massive tunnel underneath a densely populated urban area. The project utilizes a tunnel boring machine named Chris, a 26-foot diameter behemoth that methodically carves through earth and clay beneath the city. A significant issue the tunnel addresses is the problematic sewer overflow during heavy rainstorms, which historically has led to the pollution of local waterways. The tunnel will capture and store this overflow, transporting it to a treatment facility, thus greatly mitigating the environmental impact and improving the health of the Anacostia River. Throughout the project, DC Water has kept residents informed and involved, addressing concerns ranging from construction noise to local traffic disruptions. Advanced monitoring systems are in place to detect even slight movements of the ground, ensuring that the construction does not affect the integrity of buildings overhead. Next up, we have to move over to Chile, where their solar program project is an ambitious initiative to harness the country's abundant solar energy potential. The program includes several large-scale solar power projects with a combined capacity of over 2,000 megawatts, making Chile one of the leading solar energy producers in Latin America. One of the flagship projects under the Chile solar program is the Atacama Solar Plant, located in the Atacama Desert, which is known for its high solar irradiance. The plant has a capacity of 246 megawatts and features over 776,000 solar panels spread across 1,000 hectares. The Atacama Solar Plant is capable of generating enough electricity to power approximately 200,000 homes. Construction of the Atacama Solar Plant began in 2014 and was completed in 2016. The project involved extensive planning and engineering to ensure the efficient capture and conversion of solar energy. Advanced photovoltaic technology was used to maximize energy output, and the plant's design includes features such as single-axis tracking systems that follow the sun's movement to optimize panel orientation. The Chile solar program also includes the development of the El Romero Solar Plant, which has a capacity of 246 megawatts and is one of the largest solar plants in Latin America. Located in the Vallenar region, the plant covers an area of 280 hectares and features over 800,000 solar panels. The total investment in the Chile solar program is estimated at $4 billion. The program has generated significant economic benefits, including job creation and increased investment in the renewable energy sector. The development of solar energy projects has also contributed to the diversification of Chile's energy mix, reducing reliance on fossil fuels and enhancing energy security. Moving over to Chicago, we have to talk about the Lincoln Yards megaproject. This expansive plan, spearheaded by Sterling Bay, is a $6 billion redevelopment plan that is reshaping over 55 acres of former industrial land into a vibrant, mixed-use complex. Upon its phased completion, with projections spanning the next decade, Lincoln Yards aims to serve as a new epicenter for residential living, commercial activity, and cultural flourish in Chicago. A pivotal element of Lincoln Yards is its promise to create upwards of 24,000 full-time jobs during its construction phases, involving a vast array of trades and specialties. At its core, Lincoln Yards is designed to address the pressing need for urban revitalization and connectivity between Chicago's northwestern neighborhoods, effectively bridging a gap that has long segmented the city. The development encompasses over 14 million square feet of buildings, including high-rise residential towers, office buildings, and an array of retail spaces. One of the major challenges Lincoln Yards faces is integrating this vast new development seamlessly with existing infrastructure. The plan includes substantial improvements to local transit systems and roadways, including a new Metro train station, multiple new bridges over the Chicago River, and enhanced pedestrian and bike paths to ensure accessibility and reduce traffic congestion. An ambitious aspect of the Lincoln Yards project is the proposed Live Nation Entertainment District, which will include multiple venues for concerts and cultural events, capable of hosting thousands of visitors. This entertainment component is envisioned to be comparable in scale to London's O2 Arena district, albeit integrated within a larger mixed-use development. It's time to delve into the American Dream Meadowlands, a massive entertainment and retail complex located in East Rutherford, New Jersey. With a staggering cost of $5 billion, this ambitious project represents one of the largest mall developments in the United States. Officially opened in phases starting in 2019, American Dream Meadowlands covers approximately 3 million square feet. One of the most striking features of American Dream is its Nickelodeon Universe theme park, the largest indoor theme park in the Western Hemisphere. Adjacent to this is the DreamWorks Water Park, which boasts the largest indoor wave pool. The project faced numerous challenges during its development, including financial difficulties and multiple changes in ownership. Originally conceived in early 2000, the development stalled several times due to economic downturns and funding issues. Despite these setbacks, the project was revitalized and eventually brought to completion, marking a significant milestone in the region's commercial landscape. American Dream's indoor ski slope, known as Big Snow, is another highlight of the complex. It is the first indoor real snow ski and snowboard park in North America, offering year-round winter sports activities. This unique attraction allows visitors to enjoy skiing and snowboarding regardless of the season, making it a significant draw for tourists and locals alike. The construction of American Dream Meadowlands required the coordination of thousands of workers and involved complex engineering and architectural solutions to create its diverse range of attractions. The developers also focused on sustainability, incorporating energy-efficient systems and environmentally friendly practices throughout the complex. The project's strategic location near New York City and major transportation hubs enhances its accessibility, attracting visitors from across the region and beyond.
Let's talk about the Brooklyn-Queens Expressway, officially known as Interstate 278. Constructed between 1939 and 1964, this iconic roadway is not just a vital piece of infrastructure, but also a symbol of urban planning challenges. Designed by Robert Moses, the BQE spans 11.7 miles, serving as a critical link for commuters, freight traffic, and tourists navigating the city. The BQE was initially conceived as part of an ambitious plan presented by Moses to modernize New York's roadways. Built to accommodate mid-20th century traffic demands, it became a significant economic driver for the region. However, the design of the expressway, including its cantilevered triple-deck section along the Brooklyn Heights Promenade, was a marvel of its time. It lacked foresight for the growing population and vehicle load of the 21st century. Decades of wear and tear have taken a toll on the BQE, particularly its aging infrastructure, including corroding steel beams and crumbling concrete. The triple cantilever section of the expressway, carrying up to 150,000 vehicles daily, is now considered structurally unsound, leading to urgent calls for reconstruction. The BQE features multiple sections, including elevated, sunken, and cantilevered structures. The cantilevered portion, perched beneath the Brooklyn Heights Promenade, is a unique engineering feat, but presents significant challenges for rehabilitation. It supports 3 layers of traffic and a pedestrian promenade, requiring innovative solutions for repair without disrupting the bustling traffic flow or the community above. Current discussions for the BQE's overhaul include replacing the deteriorating sections with modern materials and designs to accommodate contemporary traffic demands. Estimated costs for reconstruction range from $1.7 billion to $4 billion, depending on the chosen plan. Proposals for the modernization of BQE include building a temporary roadway while repairing the cantilever. They'll probably reroute traffic through adjacent streets, or even convert sections into a boulevard to reduce vehicular congestion. Incorporating sustainable materials, advanced traffic management systems, and noise-reducing technology are integral to these plans. The deteriorating condition of BQE underscores the pressing need for investment in infrastructure.
It's time to move over to Boston now for the Green Line Extension megaproject. This extension aims to enhance public transit services by connecting the densely populated but underserved areas of Somerville and Medford to the existing subway network, thereby increasing accessibility to central Boston. Launched with major construction efforts ramping up around 2018, the GLX project completed in 2023. The project's budget, initially estimated at $2 billion, saw an increase to nearly $2.3 billion due to unforeseen construction and environmental challenges. Spanning approximately 4.7 miles, the GLX adds 7 new stations along 2 branches, one terminating at Union Square in Somerville and the other at Tufts University in Medford. These new tracks and stations are expected to serve about 45,000 riders daily, significantly easing traffic congestion and reducing commute times in these high-density corridors. The workforce required for this mammoth project varied throughout its phases, involving up to 1,000 construction workers and engineers at peak times. One of the most critical problems the GLX project addresses is the reduction of vehicle emissions by providing a reliable and efficient public transit alternative, thereby contributing to the state's environmental goals. In terms of construction, the GLX employed advanced methods, including the use of track-laying machines that allowed for faster, more efficient installation of rail lines. This project also involves substantial upgrades to existing infrastructure, such as the improvement of bridges and roads along the extension path, ensuring that the new service would be integrated smoothly with minimal disruption. Challenges encountered during the GLX project included managing complex logistics in densely populated areas, mitigating noise and disruption to local communities, and addressing cost overruns and delays, which were exacerbated by the pandemic. But we haven't talked about the Punta Catalina power plant yet, located in the Dominican Republic. This coal-fired power plant has a total generating capacity of 752 megawatts, making it one of the largest power plants in the Caribbean. Construction of the Punta Catalina power plant began in 2013 and was completed in 2020. The project involved the construction of 2 generating units, each with a capacity of 376 megawatts, as well as supporting infrastructure such as a coal storage yard, a cooling water intake system, and an ash disposal system. The plant utilizes advanced technology to ensure high efficiency and low emissions, contributing to the country's efforts to improve its energy security and environmental sustainability. One of the most important features of the Punta Catalina power plant is its environmental management system. The plant incorporates advanced emissions control technologies, including flue gas desulfurization and selective catalytic reduction systems to minimize air pollutants. The project also includes measures to manage wastewater and solid waste, ensuring compliance with local and international environmental standards. The total budget of the Punta Catalina power plant project was approximately $2 billion, showcasing the country's great efforts. The project has generated significant economic benefits, including job creation during the construction phase and increased energy supply to support industrial and commercial activities. Comprehensive environmental impact assessments were conducted to identify and mitigate potential impacts on local ecosystems and communities. The project also included measures to engage with local residents and address their concerns, ensuring that the benefits of the power plant are shared with the surrounding communities.
Next, the East San Fernando Valley Light Rail Transit Project is about connecting communities. This $3.6 billion project aims to transform public transport in the San Fernando Valley, an area notorious for its gridlock traffic. This rail transit project is being developed by the Los Angeles County Metropolitan Transportation Authority. The goal is simple: to transform how residents move through the valley. Phase 1 of the project, covering 6.7 miles and 11 stations, is expected to be operational by 2028. The new line will primarily run along the Van Nuys Boulevard and will connect key areas like Van Nuys, Panorama City, Arleta, and Pacoma. For a region where traffic can be soul-crushing, the light rail system will serve as a lifeline, helping commuters save time and money while reducing carbon emissions. What sets this project apart is the engineering technologies and planning behind it. Imagine a sleek, efficient light rail system powered by overhead electricity. The OCS system, fueled by 14 traction power substations, will ensure reliable and environmentally friendly operation. The light rail vehicles will offer ample space for up to 400 passengers. Let's discuss the sustainable design of the project here. Each station along the route will be equipped with shading devices to protect passengers from the Southern California sun. Canopies will be designed with sustainable features, such as the ability to accommodate solar panels, making the entire system eco-friendly. With a maximum operational speed of 104.6 kilometers per hour, you'll reach your destination quickly and efficiently. This project is more than just technology and speed. The community played a vital role in shaping its design. Back in 2013, residents of the area were presented with multiple transit options. Finally, they chose light rail as their preferred transit option. This means that the new system isn't just a top-down decision, it's a response to the community's needs and desires. The station designs will incorporate art that reflects the diverse cultures and histories of the surrounding communities, making each stop unique and a point of pride for residents. The future of transportation in the San Fernando Valley is taking shape. Utility relocation for the East San Fernando Valley Light Rail Transit Project began in late 2022, marking a significant milestone. This project will be completed in 2 phases, with the first phase expected to be finished by 2028. The second phase will bring 9.2 miles of track and 14 stations to the region. This will connect the Metro G line to Metrolink, making regional travel more convenient than ever. Imagine cruising through one of the busiest areas in Los Angeles without ever hitting the brakes.
But we have to talk about a gigantic station megaproject next. Miami Central Station, strategically situated in the heart of downtown Miami, Florida, is a transformative infrastructure and transit development that epitomizes the future of urban transportation in the southeastern United States. Officially opened in 2018, this expansive multimodal hub integrates commuter rail, intercity rail, and future high-speed rail, forging a new standard for transit connectivity in the region. The project, which is part of the broader Miami Intermodal Center, required an investment of over $2 billion and brought together a wide array of transportation systems under one roof. Miami Central not only serves as a vital junction point for Brightline services connecting Miami with Fort Lauderdale and West Palm Beach, but also accommodates Metrorail and Tri-Rail services, facilitating seamless travel across multiple transit lines. Spanning several city blocks, Miami Central Station is designed with a sleek, modern aesthetic that incorporates state-of-the-art architectural elements. One of the most significant challenges during the construction was integrating the new facilities with existing transit services while minimizing disruption to daily commuters. This involved careful planning and phased construction strategies, including the strategic placement of platforms and the careful coordination of numerous construction teams working in a densely urbanized area. The station's architectural design required innovative construction techniques to support its complex, multi-level structure. This includes the use of high-strength steel and reinforced concrete capable of supporting heavy rail components and high passenger footfalls, while also withstanding Florida's challenging weather conditions, including the threat of hurricanes. In terms of scale, Miami Central's construction involved moving thousands of tons of earth and laying miles of new track activities comparable to erecting a small city. It's time to explore the Kennedy Space Center, a monumental project that stands as a pinnacle of aerospace engineering. Located on Merritt Island, Florida, this iconic facility was established in 1962 and became operational during the height of the space race. The total cost of constructing and developing the Kennedy Space Center is estimated at approximately $2 billion. The Space Center spans 144,000 acres and serves as NASA's primary launch center for human spaceflight. Its construction required the efforts of thousands of engineers, technicians, and laborers working around the clock to bring this ambitious project to fruition. The center's most famous feature is Launch Complex 39, which includes 2 launch pads and the massive vehicle assembly building. The VAB is one of the largest buildings in the world by volume and was designed to assemble the Saturn V rocket, the behemoth that carried astronauts to the moon during the Apollo program. The Kennedy Space Center was not just built for the Apollo missions. It has been instrumental in numerous space endeavors, including the Space Shuttle program and, more recently, SpaceX's commercial crew missions. The facility's infrastructure includes a network of crawler transporters that move rockets from the VAB to the launch pads, a distance of about 3 miles. These crawlers are engineering marvels in their own right, capable of carrying the immense weight of fully assembled rockets. One of the significant challenges faced during the construction of the Kennedy Space Center was managing the environmental impact on the surrounding Merritt Island National Wildlife Refuge. This required careful planning and innovative solutions to ensure that the center's operations did not adversely affect the local ecosystem. To understand the scale of the Kennedy Space Center, consider that its launch pads and support facilities occupy an area equivalent to about 219 football fields. The center has continuously evolved, incorporating cutting-edge technology and infrastructure to support the ever-advancing field of space exploration. But what about a brand new tunnel that's currently being built? The Túnel del Toyo, currently under construction in Colombia, is set to become the longest road tunnel in Latin America. Spanning approximately 6.2 miles, this ambitious project aims to significantly reduce travel time between Medellin, Colombia's second-largest city, and the key port of Urabá. This reduction in travel time is expected to boost trade and economic activities in the region. Construction of the Túnel del Toyo began in 2015, and the project is expected to be completed by late 2024. The tunnel will cut through the rugged Andean mountains, presenting numerous engineering challenges. The project involves extensive geological surveys and the use of advanced tunneling techniques to navigate the complex terrain safely. The Túnel del Toyo is designed as a dual-bore tunnel, with each bore accommodating 2 lanes of traffic. This design ensures a smooth flow of vehicles and enhances safety. The project also includes the construction of access roads and ventilation systems to maintain air quality within the tunnel. One of the critical benefits of the Túnel del Toyo is the expected reduction in travel time. Currently, the journey between Medellin and Urabá takes about 6 hours by road, traversing winding mountain roads that are often prone to landslides and other hazards. The tunnel will cut this travel time to approximately 3 hours, providing a more direct and safer route. The Túnel del Toyo project is estimated to cost around $1 billion, with funding sourced from both national and regional governments. Environmental considerations are also a key aspect of the project. The construction process includes measures to minimize the impact on local ecosystems, such as the relocation of wildlife and reforestation efforts. The tunnel's design also incorporates advanced drainage systems to manage water flow and prevent flooding. Up next, it's time to investigate the Goethals Bridge. This project is a significant architectural feat in the United States, linking Elizabeth, New Jersey, to Staten Island, New York. The bridge was originally constructed in 1928 and underwent a massive rebuilding project that began in 2014 and concluded with the opening of its eastbound span in 2018. The total project cost was approximately $1.5 billion, highlighting its scope and the investment required to modernize critical infrastructure. Designed to replace an aging structure that could no longer efficiently handle modern traffic volumes, the new Goethals Bridge features twin spans, each supporting 3 lanes of traffic, additional shoulders, and a pedestrian and bike pathway that will be completed in a future project phase. One of the most notable methods used was the modular construction approach. Large segments of the bridge were prefabricated off-site and then transported to the location for assembly. This method not only sped up the construction process, but also minimized environmental impact and disruption to the existing traffic. The Goethals Bridge project was a technical challenge, involving the installation of 60-foot-tall piers and the lifting of massive 900-ton segments into place. The bridge spans a total length of 1.4 miles, with each of the twin spans stretching approximately 900 feet in their longest span section, requiring precision engineering and construction expertise. One unique aspect of the Goethals Bridge is its focus on sustainability. The project included measures to protect the local marine environment and featured the extensive use of recycled materials. Moreover, the bridge's design incorporates energy-efficient LED lighting and has provisions for future smart transportation technologies. Next up, it's time to investigate the Huey P. Long Bridge. Since its original completion in 1935, this bridge has stood as a vital link for both rail and vehicle traffic between the eastern and western halves of the metropolitan New Orleans area. The bridge underwent a massive expansion and renovation project that began in 2006 and concluded in 2013, drastically enhancing its capacity and safety. The project's scale was monumental, with a budget of $1.2 billion, making it one of the largest public works projects in Louisiana's history. This extensive modernization aimed to address the bridge's notorious narrow lanes, which were often seen as a bottleneck for traffic and a hazard for drivers. Originally constructed during the Great Depression as part of a nationwide infrastructure initiative, the Huey P. Long Bridge was named after the famed Louisiana Governor Huey P. Long, who was a major proponent of infrastructure projects. At the time of its initial completion, it was among the longest railroad bridges in the United States, featuring a continuous truss design that was a marvel of that era's engineering capabilities. The renovation project expanded the bridge's width, adding wider traffic lanes that increased the overall width from 18 feet to an impressive 43 feet. This expansion included the installation of new roadways and rail lines, significantly increasing the bridge's traffic capacity and safety. The bridge's elevation was a significant challenge, situated 135 feet above the Mississippi River, which necessitated complex vertical construction techniques. Engineers employed high-strength, lightweight concrete and advanced steel composites to handle the loads and stresses involved with such height and width, ensuring long-term durability against the river's powerful currents and the region's frequent severe weather. The construction work involved around 300,000 cubic yards of concrete, enough to fill 90 Olympic-sized swimming pools. But we have to travel over to Peru next. where the Peru LNG project is a major undertaking that is designed to export liquefied natural gas from the country to international markets. Located in Pampa Melquirita, the project includes a gas liquefaction plant, a marine terminal, and a pipeline that transports natural gas from the Camaisia gas fields in the Amazon basin to the coast. Construction of the Peru LNG project began in 2006 and was completed in 2010. The total cost of the Peru LNG project was approximately $4 billion. The liquefaction plant has a capacity of 4.4 million tons per year, making it one of the largest LNG facilities in South America. The project includes a 408-mile pipeline, which traverses diverse terrains, including the Andes Mountains and coastal plains, to deliver natural gas to the liquefaction plant. Advanced engineering solutions were required to ensure the safe and efficient transport of natural gas, including the use of horizontal directional drilling to minimize surface disruption. The project also incorporated state-of-the-art technology for gas processing and liquefaction, ensuring high efficiency and low emissions. The total cost of the Peru LNG project was approximately $4 billion. Environmental and social considerations were integral to the Peru LNG project. But have you ever heard of the Intel semiconductor plant? With an estimated cost of $20 billion, this state-of-the-art facility represents one of the largest and most ambitious semiconductor manufacturing endeavors in the United States. Located in Chandler, Arizona, the project began its construction in 2011 and has seen continuous upgrades to remain at the cutting edge of semiconductor technology. The plant spans several 100,000 square feet and is designed to produce Intel's most advanced chips, including those built on the company's latest process technologies. A standout feature of the Intel semiconductor plant is its use of advanced manufacturing techniques, which enable the production of chips with transistors measuring just a few nanometers in size. This precision is essential for creating the powerful and efficient processors that drive today's electronics, from computers and smartphones to data centers and AI applications. The facility is also a model of sustainability and environmental stewardship. Intel has implemented numerous green initiatives at the plant, including energy-efficient designs, extensive water recycling systems, and waste reduction programs. Intel's plant plays a critical role in the company's global supply chain, helping to meet the ever-growing demand for semiconductors. This demand has been driven by the proliferation of digital devices, the expansion of cloud computing, and the increasing integration of artificial intelligence into various sectors. The plant's production capacity is essential for ensuring that Intel can supply the chips needed to power the technological innovations of today and tomorrow. The strategic importance of the Intel semiconductor plant extends beyond its manufacturing capabilities. It represents a significant investment in the U.S. economy, creating thousands of high-tech jobs and fostering innovation in the semiconductor industry. The plant also contributes to the nation's technological independence, reducing reliance on overseas chip manufacturing and enhancing the resilience of the supply chain. We have to talk about the Second Avenue Subway Megaproject next, located in New York City. Officially part of the Metropolitan Transportation Authority network, this new subway line runs along 2nd Avenue on the east side of Manhattan. The project has been in the conceptual and developmental stages since 1920, but saw its first phase completed and opened to the public on January 1, 2017. Phase 1 of the 2nd Avenue subway cost approximately $4.45 billion and included 3 new stations with a new terminal at 96th Street. The construction of the 2nd Avenue subway involved approximately 6,000 workers at various stages, tackling complex urban engineering challenges such as tunneling beneath densely populated areas and avoiding disruptions to the existing utility infrastructures. This necessitated the use of tunnel boring machines, which are sophisticated pieces of equipment that can efficiently cut through New York's bedrock while minimizing vibrations that could damage building foundations above. The 2nd Avenue subway covers a planned total length of 8.5 miles once all phases are complete. To put the scale of this project into perspective, the total length of the new subway line would be equivalent to more than 146 football fields laid end to end. Each station is built with expansive, column-free platforms and high ceilings to enhance passenger comfort and safety, a notable departure from many of the city's older subway stations. The 2nd Avenue subway has faced numerous challenges, including budget overruns and delays primarily due to the complexities of constructing a new subway line in one of the world's most built-up urban environments. Comparatively, the cost and scope of the 2nd Avenue subway are similar to those of the Crossrail project in London, although the latter is even larger in scale. It's time to explore the Crescent Dunes Solar Energy Project next, which is a groundbreaking renewable energy initiative located near Tonopah, Nevada. Completed in 2015, this state-of-the-art solar power plant represents a significant leap in solar energy technology, with a price tag of $1 billion. The Crescent Dunes Solar Energy Project was developed by Solar Reserve and is renowned for its innovative use of concentrated solar power technology. Unlike traditional photovoltaic solar plants, Crescent Dunes uses a central tower surrounded by over 10,000 mirrors, known as heliostats. These mirrors track the sun and focus its energy onto the tower, heating molten salt to extremely high temperatures. One of the key advantages of this system is its ability to store thermal energy, allowing the plant to generate electricity even after the sun has set. The Crescent Dunes facility has a capacity of 110 megawatts and can provide power to approximately 75,000 homes. Building the Crescent Dunes Solar Energy Project was a massive undertaking, requiring the coordination of over 1,000 workers during peak construction phases. The project faced numerous challenges, including logistical hurdles related to transporting and assembling the large number of heliostats and constructing the central tower, which stands at 640 feet tall. The project's location in the Nevada desert posed additional difficulties, such as extreme weather conditions and the need to protect the fragile desert ecosystem. Despite these challenges, the project was completed on time and has set a new standard for solar power plants worldwide. It's time to move over to the Blue Plains Tunnel next. This massive infrastructure project is a critical component of DC Water's Clean Rivers project, aimed at drastically reducing combined sewer overflows into the Anacostia, Potomac Rivers, and Rock Creek. The tunnel, completed in 2015, stretches over 2,400 feet in length and is located up to 160 feet below the city's surface. This tunnel was designed to capture and store sewage and stormwater runoff during heavy rains, redirecting up to 100 million gallons of overflow that would have otherwise spilled into local waterways. The project's total cost was approximately $580 million, making it not only one of the largest environmental projects in the city's history, but also a significant investment in sustainable infrastructure. Constructing such a vast underground structure in an urban environment presented numerous challenges. The project team had to navigate around existing utilities and subway tunnels, requiring precise mapping and innovative tunneling techniques. The tunnel was constructed using a tunnel boring machine named Lady Bird, a massive piece of machinery that excavated the tunnel's path while simultaneously laying reinforced concrete to form the tunnel walls. The scope of the Blue Plains Tunnel can be compared to the length of nearly 80 football fields laid end-to-end. The concrete used in the project would be enough to pave a 2-lane road for several miles. Special features of the Blue Plains Tunnel include its state-of-the-art odor control systems designed to treat air before it is vented to the surface, ensuring that the surrounding neighborhoods are not affected by unpleasant smells. Let's travel to Los Angeles for the LAX International Airport Modernization Project. The initiative is slated for completion in 2028 prior to the Olympic Games and is currently one of the most significant infrastructure undertakings in the United States, with a budget exceeding $14 billion. Spanning over 1,700 acres, the airport project aims to accommodate increasing passenger numbers, projected to rise to over 100 million annually by the end of the decade. This extensive modernization includes the construction of new facilities, enhancement of existing structures, and the introduction of innovative transport systems. The project involves the addition of more than 3 million square feet of terminal space, effectively increasing the airport's size by 25%. This addition is equivalent to about 42 football fields laid side by side. The centerpiece of the project, the midfield satellite concourse, alone spans 750,000 square feet, featuring 12 new aircraft gates. Additionally, the project features a centralized utility plant upgrade that employs 6,000 solar panels and an advanced water reclamation system, which together aim to cut energy consumption by up to 25%. Challenges faced during this vast project include maintaining airport operations during construction. Solutions have involved intricate phasing of construction activities and the use of real-time analytics to manage flow and logistics across the sprawling site. Let's travel over to the next megaproject, the Los Angeles County Metro Purple Line Extension. which is a massive $9.3 billion rail project that's stretching the definition of urban transit development. Extending the Metro Purple Line by 9 miles, this project is not just about adding tracks. It's about seamlessly connecting key sectors of the city, from the skyscrapers of downtown LA to the vaunted gates of the University of California. Slated for completion in 2027, the Purple Line extension is currently a hive of activity with over 5,000 workers bustling daily. Building a subway in an area prone to earthquakes demands cutting-edge construction techniques. The team employs advanced tunneling methods, including earth pressure balance machines that delicately burrow beneath the city, ensuring minimal disruption to the surface life and structural integrity of the buildings above. This project solves critical transportation problems in one of America's most congested cities by offering a reliable, high-speed alternative to road travel, effectively reducing traffic and the city's carbon footprint. Once operational, it's expected to serve about 4,900 citizens and riders daily. Comparing this to the scale of other megaprojects around the globe, the Purple Line extension's budget overshadows the construction costs of the new Wembley Stadium in London, illustrating the monumental investment in public infrastructure and the future of Los Angeles. The project's integration of smart technology systems for maintenance and operation sets new standards for public transportation. Next up, we have to talk about the Arena da Amazônia, located in Manaus, Brazil. This iconic structure not only serves as a venue for major sporting events, but also as a cultural and community hub for the region. Construction of the Arena da Amazônia began in 2010 and was completed in 2014, just in time for the World Cup. The stadium has a seating capacity of approximately 44,000 and features a distinctive design inspired by the Amazon rainforest. The roof structure resembles a basket weave, reflecting the local cultural heritage and providing an aesthetically striking appearance. One of the significant engineering challenges of the Arena da Amazônia was its location. Manaus is situated in the heart of the Amazon rainforest, presenting logistical challenges for transporting construction materials and equipment. The project required meticulous planning and coordination to ensure timely completion while minimizing the environmental impact. The stadium incorporates several sustainable design features, including rainwater harvesting systems, natural ventilation, and energy-efficient lighting. These features not only reduce the environmental footprint of the stadium, but also enhance the comfort and experience of spectators. The use of local materials and labor also contributed to the sustainability and economic benefits of the project. The Arena da Amazônia has hosted numerous international and domestic football matches, as well as concerts and cultural events. It has become a symbol of pride for the people of Manaus and a key attraction for tourists visiting the region. The stadium's design and construction have also received accolades for their innovation and sustainability. It's time to investigate the Interstate 70 East project next. This ambitious project, stretching 10 miles from Brighton Boulevard to Chambers Road, is designed to modernize and expand one of the busiest and most critical highway corridors in the state. Launched in 2018 and completed in 2022, the project has an estimated cost of $1.2 billion. One of the most groundbreaking aspects of the Interstate 70 East project is the reconstruction of a 1.8-mile segment of the highway that includes lowering the interstate between Brighton and Colorado Boulevards and placing a 4-acre parkland cap over a portion of the lowered interstate. This innovative design not only facilitates connectivity between the divided neighborhoods of Globeville, Elyria, and Swansea, but also adds much-needed green space to the urban environment. The project includes the widening of the interstate to accommodate one new express lane in each direction, enhancing throughput and reducing travel time. The total width of the newly designed segments reaches up to 300 feet, including new service roads and auxiliary lanes designed to improve local traffic flow alongside the interstate traffic. Construction of the Central 70 has involved massive logistical challenges, including the management of around 5,000 daily construction workers and the strategic phasing of demolition and construction to keep the interstate operational throughout the project. Let's take a look at the impressive Mercedes-Benz Stadium, home to the Atlanta Falcons and Atlanta United FC. Situated in the heart of Atlanta, this sports and entertainment facility is a testament to modern construction, with a staggering cost of $1.6 billion. The Mercedes-Benz Stadium project broke ground in 2014 and opened its doors in August 2017. Designed by Hawk, the stadium covers approximately 2 million square feet and boasts a seating capacity of 71,000, expandable to 75,000 for major events. The stadium is notable for its innovative retractable roof, which resembles a camera aperture and can open or close in just under 10 minutes. This unique design allows the venue to host events in both open air and climate-controlled environments, providing flexibility for a wide range of activities. One of the standout features of the Mercedes-Benz Stadium is its 360-degree HD Halo video board, which is the largest of its kind in the world. This massive screen, which spans 1,100 feet in circumference, ensures that every spectator has a clear view of the action, no matter where they are seated. Additionally, the stadium is equipped with cutting-edge technology, including high-speed Wi-Fi and numerous LED displays throughout the venue. Constructing the Mercedes-Benz Stadium was a massive endeavor, requiring the efforts of over 4,000 workers during peak periods. The project faced several challenges, including the complexity of the retractable roof mechanism and the need to integrate numerous sustainable design elements. These sustainable features include a rainwater collection and reuse system, a LEED Platinum certification, and over 4,000 solar panels, making it one of the greenest stadiums in the world.